Hello. Today we're pretty much continuing from where we left off yesterday. David, thank you for the tier 1 sub. Hello, everyone. Double audio. Let me take a look here. Oh, that. Boom, fixed. There we are. Yes, so hello, everyone who's hanging out and chatting before the stream officially starts. A couple of things here before we get started. I have the... Seriously, this was... Oh, wait, I bet it's because I gotta click here. Boom. This was working. What? Ow! What? Seriously, I had this working. This is the new... The big keyboard. I had this working. What happened? What? Like, I can manually change things. Like, there we go. There's that. But I did it though. What? All right, let me figure this out. If I press that one, oh, that's maybe something going on there? No? Why is it changing those? It changed the corner? Yeah, this is, it's doing, these should be the small window keys, and those are working. This shouldn't change the small window. I don't know why that's happening. Let me check my settings here really quick, because I kind of need those to work. Okay. All right, I may not have properly configured this. One moment here, I guess. Oh, I know what happened. Oh, totally great. All right. All right, this is going to take a moment here. I'll change over to this while I describe what is happening here. I'm now realizing all of the shortcuts I just set are broken. I was setting the shortcuts on my offline profile that doesn't have the ability to stream so that I can't accidentally go live or something. And I'm now realizing that the shortcut keys do not transfer over from that. So I have to go ahead and re-add all of these right now so that this will actually work on the live version. Rather unexpected. I should have realized that was going to happen. I just need a moment here. Oh, I did that wrong. The setup for this is kind of weird too. It's really confusing. OBS doesn't have like a natural way of like allowing you to enable something and hide something else at the same time. So now, bingo, that's working, but none of the other keys are. So I still need to get that going. Yeah. Sorry, I'm not responding to everyone here. What is the keyboard? This is a Cherry G86 74111. That is the full model, everything. It's just a Cherry point of sale keyboard. You can find it by looking up Cherry LPOS. But yeah, it has configurable macro keys up top, and I have these set up to do different things. All right, I'm no longer allowed to use Python as a calculator. And I think I decided what I'm going to do with that. I might have a, yeah, I'm not even sure how you type the Euro key thing there. It is there. I'm not sure how you do it. Anyway, I think I know how I'm going to handle the Python calculator being banned. If I use the Python calculator during the stream after it's been banned, whoever redeemed it, I will add their name to a little scroll that happens at the end of the stream and will tally up however many times I screwed up, although I've never screwed it up yet, so I don't know how much of a thing that is going to be. Right Alt 5, is that really going to be it? Okay. I don't really have a good place no, I have, that's right, I have a right text editor open. Alt right 5. No, that just typed 5. Menu 5. Nope. Wait, now 5 just... Okay, weird. Control Alt, it could, I don't know. That might actually be shortcut keys. I don't want to mess with that. It's depending on the keyboard layout of the OS. Oh, all right. Oh, that could make sense. If it's just like a normal system shortcut and then it adds it as a legend on here. Okay, that would make sense. Okay, I got to fix some other stuff too. I think that will work, but then that key doesn't. But I can do that. That's the schematics. We'll be getting into that. VJ, that one's working. Okay, but I have no way. I don't think that works. Oh, that does work. Will this work then? This does work. Okay, weird. All right, so here's a thing I did. We have a split camera view now. So that we can do 2 shots at once. One, well, I can switch them out. So if I turn on the Nikon here and get that going, then we can see like 2 angles of this thing at once. Why is that not working? Let's go back to here and troubleshoot that. Camera B. Oh, I just removed it entirely. Okay. Black magic device. Add. This is input 2, 3, 4. I don't remember. Square hips, short shoulder, or relief. This is. Oh, this is going to the old intensity, not the new capture card. There, boom, sort of. 1080p 30. There we are. Okay, so there's that. Now I have to put it in the correct place. Boom, that's not the correct place. That is, and now we can go back to here and we can see split view. There we go. Echo again? How? What? Okay, here. Mic input, no echo there. How was there echo again? Okay, let me test. Oh, this. Yep. Okay, got it. Oh man, it is complicated how many things I have going on here, but it works, so you know it's worth it. Oh man. All right. So I'll go ahead and I don't know what we're doing with this today. Might use it. Don't know. Can make it slightly brighter or not. How about this way? Ha ha. There we go. Anyway, yeah, that looks good. All right, let's turn it off so it doesn't burn the sensor. Yes, we are going to take a look at the drive today. So let's actually start the stream here. You know, what are we? Only 10 minutes in. Okay. So, hello everyone. I hope your days are going well. So we have a couple of things we're going to try and do today. I've already taken the floppy drives apart here. I have them separate. Running them like this is a little complicated to test because we can't run them upside down. So I actually kind of have to leave them sideways, which I'm not really thrilled with. But I don't have a lot of other choices if I want to be able to access both sides here. So we're going to do this. I did remember this. Well, you don't know what this is. This is oil. So we can oil the stepper motors and see if that makes a difference. So someone mentioned jumpers on Discord. Yes, so we're going to look at that. That's part of why I have the manual open here. But if we take a look at this, this is actually really hard to see on here. So let me slide the whole thing over a bit. There we go. All the jumpers, as far as I can tell, are identically configured. You know what? Let's use the Nikon. This will be better for this. So, it's a little tricky, but I think I can make this work. Come on, there we are. Please cooperate. Let's see. I started playing with the drives without us. All I did was take them out, so we wouldn't have to sit through that again, because you guys have already seen me remove the drives. So that was all I did. Okay. So, if we do this, okay, I think that'll work out for seeing all of the jumpers here. So, there's nothing up here for jumpers. Then as we go down, the first set of jumpers we'll actually encounter is this. So this is a punch-out jumper block. There's one punched out there and one punched out there. And then there are two jumpers right there, one jumper over here on DL, and then down here is the drive select jumper. So the jumpers we have are two punched out on the block, on the ends of that, and then the second position on that. If we go down to here, we have two jumpers on there. There are two holes punched out there, and then one in the second position there, and then the drive ID is different. I don't see anywhere else that the jumpers are different, so I'm not sure what the person on Discord saw. Excuse me. So I don't know what might be configured differently in that regard. Now, an additional thing that was pointed out to me, Ben on here was actually looking at, I can bring up the laptop and we can go over to here, was looking at the schematic, and it turns out that the jumper, whoops, right here under RN10, which is, ooh, that's interesting. Okay, let's hide. Did I? Hold on, I may have messed it up here. There we go. Okay, RN10 is the block right here, and there is one HA right there, which supposedly connects to the solenoid. So we might be able to try jumpering that. But yeah, that's a thing to check out. And then I tried looking where the solenoid wires are coming from, and they are really hard to track down. But I think it might be these top two. We'll try and figure that out a little bit more as we go along here. One other thing that we have going on today, though, is I got the Greaseweezle in. And I'm not sure how well this is going to work for testing these out. So I'm going to start out here by doing the testing with this stuff with the CryoFlux, since I know how to use that. And then hopefully we'll get these working, or we'll give up, and then we will try and test this out for reading and writing discs. But yes, I have the Greaseweezle, so we can test that out today. So, yes. People seem to be confused by the spelling of Greaseweezle. The repo is a Z. So I don't know. I don't know what to tell you. The name of it, as far as I can tell, has a Z in it. Matter of fact, if we do this and I try and refocus this into there, which it doesn't seem to want to do. Ooh, I'm getting close. Let me just crank the ISO here. So I can just show you on the thing it's got a Z as well. Brighter. Here we are. And Z, Greaseweezle. So yeah, it has a Z in it. So yeah. Greaseweezle case matches the shirt? Yeah, kinda it does actually. It's funny. So yes, looking forward to that. So yes, you know what? Yeah, so, okay. I just feel like I haven't been able to chat that much, but I had a lot of stuff that I wanted to talk about first. So here we go. Scarlet Swordfish, hello, since your first time chatting. What's a Greaseweezle? It's one of multiple types. Well, actually there are multiple variations. It's a board that has a USB interface that you can then plug into a floppy drive, and you can control a floppy drive from a modern PC with it to read and write data. The reason that you would want to do that as opposed to an old computer is the way that this allows you to interface with the floppy drive allows you to get a much lower level signal from it, so you can have higher precision backups of the disks. That's why. So, yeah. Yeah. Hiram, I'm not sure why you're asking about it. Let's see. I have a Zoom floppy. Ooh, that's familiar. Is that just Commodore? Supposed to archive a bunch of C64 floppies for a friend. Made as a youngster, but kind of moldy. Any suggestions for cheap cleaning? I've not done that. There are 3D printed frames that you can get to do that kind of thing with, where you can then rotate the disc easily, and then maybe I would just use a microfiber cloth, kind of like what I had here that I was cleaning the rails with. This is really soft, that shouldn't damage it, so that might be the best way to go. See. Oh, you didn't know what it was, Hiram. Oh, okay. Yeah, it's just a different thing I have that's very similar here, and this is what we're going to use first, is a CryoFlux. It's almost identical in its functionality. USB to floppy connector, so that you can connect to floppy drives from a modern computer with it. So yeah, the main thing here is trying to have a low-level control over the floppy drives. Humid being, thank you for the gifted sub. See, no idea if it's CBAM only though. I'm not sure about the Zoom floppy. These are platform agnostic. They'll work with pretty much everything. So that's why these are great. And you can read disk formats you shouldn't be able to read with other kinds of drives too. Like you really can't normally read Commodore disks with something like a PC 5¼ inch drive, but you can with one of these because of how it works. So yeah. See, I'm still looking for a GoTech I can connect to DOS, Mac OS 7, and all that stuff. Unless you mean just something different than a GoTech, because you can get GoTechs for pretty cheap, even on Amazon. They're really not bad. I think I've paid like 12 bucks each for mine. So, yeah. Floppy fits in the drive. It can read the disk. Yes, for the most part, with the potential exception of the hard sector stuff, but I need to look into that more, because I think so far everything can read hard sectors. I gotta figure out how. So, but yeah, so let's try and figure out what's going on with these drives here. So unfortunately, I did glue the cable into the bad drive. So this cable is glued on here to hold it in place. So I'm not 100% sure. Maybe I should just undo the ribbon connector from this so that it can be loose and not yank on it. So let's see. Mexico Random, hello, since it's your first time chatting. Let's see. I don't think there's one for Max. Yeah, I don't think there's one that can at least do all of them. I think there is something, I forget what it's called, but I'm pretty sure there is a thing that can interface over Floppy for Macs. So aren't GoTech specialized for the system you connect them to, or is that just advertising? That's just the advertising, Hiram. All the GoTechs, as far as I'm aware, can be reconfigured. Like the one that I have floating around here somewhere. Where did I put it? I had too much stuff going on. Is it up here? Okay, well, I don't know where it went, but on that one I have labels on it that I put on there that tell me how to reconfigure it for Atari ST or PC, because I've used it with both. So you can just reconfigure the jumpers on it to work with the system that you want. I don't know where it went. It's a good thing I don't need it today. So yeah, that's annoying, but all right. So yeah, you can just reconfigure it to do whatever you need. So see, have to match the RPMs for 1.2 and 360K. It's not that difficult. So you don't have to worry about that kind of thing, Tiki Motel. That's handled by the GoTech. As long as you toss a disk image in there, it'll figure that out based on the size. So from what I read, the hard sticker stuff should work, with the only limitation that the index circuit of the drive could be too slow to react to multiple holes. Interesting. So Helencroft, I was actually looking at the help output for the Greaseweezle, and it has some kind of option to fake index holes, and I'm not sure how that works. I think it'll like just generate them itself rather than use the ones from the floppy drives, and I don't know how that works. I'm wondering if that's how it's being done for the hard sector discs, but I'm not really sure because it's really weird. Overall, the Greaseweezle looks like it's going to be a lot harder to use. So that's part of why I want to use the CryoFlux first, because I know how to use it. Ultimately, though, I want to use the Greaseweezle, although unfortunately it seems like there's no GUI for the Greaseweezle, so that's a thing. Flash Floppy is open source firmware. Yes, yeah. So you will probably want to reprogram your GoTech to have Flash Floppy on it, because it makes it way easier to configure and do other stuff. So you'll probably want that. It's a pain, and it's a bit spooky. Yeah, Hans, I am thinking about writing my own GUI, actually. That thought had crossed my mind. It'll be a pain, but I may actually do it, because I want to use it for streams, and streams are a visual medium where the effort would be worth it. So, ooh, don't want these separating. See, your virtual camera person's having a moment. Yeah. See, IPA with cotton swab should work. Ooh, I'm not a fan of putting IPA onto floppy disk media, because IPA, there's already a, ooh, hello. Let me look at that. It always drives me nuts when people have a GitHub project that is specifically for something visual, and then they don't include screenshots in it. Okay, so Irondale, do you know, does that GUI actually show like flux data, or does it only just automate the parameters? Because that looks like it automates the parameters, which is useful. I was kind of hoping to be able to show flux data. But maybe I could extend that to show flux data. Let's see, there are multiple GUIs. Oh, okay, I'm probably gonna have to look into this a bit more. See, Adrian Black had to re-image a 8-inch floppy to IMD disk because the source 360K was imaged with the wrong RPM on a 1.2 meg drive. That's weird. Yeah, I don't know. I haven't had the chance to watch Adrian's 8-inch floppy stuff. I should really get into that at some point here. See, are you full-time streamer? Do you have a different job? I am Twitch streaming and doing YouTube, so I'm doing both of those. That's what I do. See, Irondale, no, you have to use HXC tools to view actual flux data. Okay, well, the CryoFlux will show you the per track or per sector, I'm not sure which it is, stream as it comes in, which has been helpful for identifying stuff. So, Dave Starbuck, thank you for the Prime sub. So, let's see, Adrian just used the wrong command line parameters for CryoFlux. He didn't have to image the disk. Oh, okay. Yeah, it gets to be confusing, so I don't blame him. Okay, so I'm going to take a picture of that real quick like. How are these wired? Okay, that splits off of there. Okay. We're going to try and figure out what on earth is going on with these drives. Unfortunately, the power supply is... These cables are super short, so I haven't really been able to... I didn't look too much of this stuff. I was just trying to get prepared for the stream so we'd know what all we need to do today, because it can be kind of weird. So I wanted to run these side by side, but this cable is so short that I really can't put this drive down. Could I... You know what? I might be able to flip the whole thing around. Let me try that. That might work. I might have an idea here. So if I unplug that, put this on its back, put this down here, I can run both like that. That'll work. Oh wait, no, I gotta be able to plug in the actual power cable. If I swap these and do this. Oh, it's so close. That might work. That backwards. Key to the right. No, that should work. Let's see. Let me catch up. Let's see. We flipping floppies? Yeah, a little bit. Not quite flippy disk. AJ Slim, thank you for the Prime sub and for the 4th month in a row. Wow. Yeah. See, you need to clone yourself. One buddy is not enough for so much energy and enthusiasm. So you're saying I need to split it out to multiple? Bifurcate? Oh gosh, come on, plug in. There we go. And then will that actually reach, or... Yeah, I'm not thrilled with that. Let's put that back there. Okay. This one can plug in though. That'll reach just fine. There we are. Now we have these down. That's perfect. Okay. Then I can plug in stuff right there. Plug in AC over here. If I flip it around, bingo. Okay, now I can try and shimmy the whole thing over. Oh, we have a hype train going. Okay, Commander Keen, thank you for the 286 bits. Whoa, Dave Starbuck, thank you for the 5 gifted subs. Wow. Oh, that's hilarious. You just gifted a sub to Adafruit. Yeah. They've actually seen at least one of my streams, the one where I got the 8-inch floppy drives working. They did a little mini post on their website about it. So I think someone there watches the streams. That's kind of fun. All right. I want to shift all this over so I can get it closer. Excellent. Okay, so the wonky drive is that one. Let's see, 21. Then they need to be in a horizontal position. So Wantonamek, let me bring up the manual here again. If every follower has a sub, it goes to unrelated Twitch users. Yes, that's true. but I wouldn't be. I think the way that it also works is if there's no one watching who isn't subbed, it'll go to people who have watched in the past. So Adafruit may not be here now, but if they did watch at some point, it'll happen, or they could get it. So I think that's how it works. So, yes. What am I doing here? Let's see. Oh yeah, I've definitely bought some Adafruit stuff. Laptops, go to capture. So it says somewhere in here, let me figure out where it says it. Bingo. Keemtrack 842 can be mounted in any plane horizontally for front loading, vertically for front loading, or vertically for top loading. Whoa! You can have it pointed up? I want 8-inch floppy drives built into my desk. Dude, that's awesome. But anyway, however, when the disk is mounted in a horizontal front loading position, it must be oriented such that the in-use LED indicator on the front bezel is below the door, as shown in the illustration. Basically, it can't be upside down. That's the only position it doesn't work. And I think that's because it has the springs used to push the head clamp. So, yeah. So I'm getting used to this lunchtime stream thing. Gonna have to start doing this every day so I have something to watch at lunch. That's kind of the whole reason that I stream at this exact time, is to try and hit lunch here and afternoon in Europe. So yeah. 1H floppy's built into a waterbed. Let's see, eject that floppy stuck in the ceiling. Yeah. Let's see. Also, hello, Soggy Electric. So let's get back to... oh, I didn't get that fixed. That's fine. Let's get back to this. So let's just baseline retest these now that they are out of the case, just to make sure that they do the same thing that they did yesterday. And this one will work, this one will not. So we will use the CryoFlux again, because we know how to use that one and how it'll work, what it'll work with, all that fun stuff. Let's see, now imagining 8-inch drives integrated into the desk. Yes. Vertically, that's the real kicker. Just have it like toaster, just like, here's your, you take your disc out and then you just drop it right into the desk. That'd be amazing. Because you can look, Terrace 80 Model 2s have a desk that's built in where you'd like reach under and put the disc into the desk like that, which is also really cool. But like topside, like, man, just boop right in there. That would be crazy. I want that. That would be super cool. Like in that one Byte magazine ad, yes. I think we looked, I don't think it was Byte. It was, someone mentioned like a specific version of the IBM floppy, or maybe I was looking at the sleeve trying to figure out what format the floppies for these were, and I looked up the IBM desk, and they were like that. I was most excited about that because I was kind of hoping that they stuck out like that much as they were being run, because technically, if you could clamp that and then get the head up there, you could leave as much of it as exposed. Well, I guess you need the index. You could leave the label exposed as you read the drive, and I thought that was how it worked, but it was just, yeah, IBM 7340, I think that was it. I think that was just them doing the showing the floppies going into there. Commander Keen, thank you for these 6 gifted subs. Oh, you have the Model 2 desk, J-Metal? That's awesome. I'm jealous. I would just like to get a Model 2 to start. Let's see, Centurion built a computer that was built into a desk, had an entire 14-inch Hawk hard drive bolted to the underside. Wow. Oh, man. Yeah, finding that's probably going to be crazy hard. Yeah. I don't envy that quest. Oh, this is not doing super great. That plastic is brittle on the connector. All right, there's that. Plugged into the CryoFlux. Drive ID's looking good. Let's get the cable going. I should also get power cable for the drive handy. I guess I can plug it in since it's got a power switch. And get that fully plugged in. There we are. Let's see. Wow, the office is enormous. It's 900 square feet, so it's about the size of a bigger apartment, I would say. But yeah, it's this room is 30 feet long, which is how I can do this camera angle. The camera is about 10 feet away from me. That's how you can get a view that looks this nice with the amount of compression and focus. So I'm really happy I found this place. So let's see. Vertical would be a dust hazard for the drives though, wouldn't it? It would. I think it would be worth it. Just for the awesomeness. Ooh, you found more platters. That's awesome. I have not found a single extra control data platter for my, what do you call them? Data general drives. So. Starhawk, thank you for the 100 bits. Happy birthday. Let's see, it was I drove all the way to Tulsa to pick up my Model 2 and drive expansion. Then a few months later, a desk that was missing the drive expansion popped up locally. Oh, that is hilarious. Let's see. Time to over-engineer some covers? Yes. Oh, yeah, like plastic flip-ups. Ooh, that would be good, too. Although, really, if you look at the front of these, if you just closed them when you're not using them, it would cover the stuff, so it wouldn't actually be a problem. So, also, yeah, the one with the bad switch there. I was looking at this. For some reason, these have a solenoid by the eject lever. Like, they could be electronically ejected. I didn't realize that. That is so weird. Now I'm wondering if there's a signal that I could send to have it push out the disc. Because it's spring-loaded, you mean it could totally do that. It would be like a Mac, except it wouldn't go all the way out. It would just be like partial, and then you could pull it. But yeah, that's a thing. The other solenoid, though, is like right there on the other side of the board. So this is going to be hard. Let's see. So I think I can just turn these on now. Boom. All right. All that's dust. All that's going. All right. So this is the drive that works. Let's try it out here. Alrighty, I'm gonna bring up the CryoFlux software over here. In a moment, I wasn't prepared, it seems. And I need to close out my connection to my server so it performs a lot better. There we are. Let's see, Finding Diablo. Ooh, hold on. Some 5 1/4 inch drives had automatic ejection, so it's possible. Ooh, that would. Yeah, it really seems like it should be capable of doing it. So, see, Finding Diablo hard drive platters are kind of easy, as they were used by computers ranging. Yeah, there's a bunch. So, Bacon Cheese 22. Hello, since it's your first time chatting. Let's see, we're back at it. Another day, another struggle. Yeah, I'm not sure how well it's gonna go, but we're gonna give it a shot. So, yep. All right. Here we are. I swear there's a lot more noise going on this time, but we'll see how it goes. So, here is the laptop GUI going. Drive 1 calibrates this one. I didn't put the disk in and then turn it on, did I? I think I did. Oops. Well, it's a good thing we've already imaged it, and it's a copy. Wasn't this drive 1? Drive 0. Calibrate. Now it's on this. All right. Weird. Okay, I have these backwards, I guess. I don't know how. That does not make sense. Okay. You turn it on before inserting the disc? Okay, good. I feel better. Sounds a lot like a dot matrix printer. It really does, yeah. So, okay, I don't know why that's drive 0, but okay. Test. I don't think that actually is. File, settings, advanced, 76. 76. Okay, we're gonna go like, yeah. Oh man, I think running it sideways has kicked up some new dust. Start. Sure. Whoops. Okay, it's somehow the IDs are backwards. I don't understand. Because now Drive Zero's working. Put little labels? Yeah, I will. Let's stop. I'm gonna do this. Pop this. They've changed, because this is the one. Here, let's do this. Boom, boom. This is the one that's hard to open. That's the one that was Drive 1. Okay, this is that. This is the one that's super easy to open. That was Drive 0. So this one I expect not to work correctly. This one won't lower the head. But let's see, I guess. Drive 1. Start. Yes. Yeah, it's not lowering the head. Okay, so somehow the drive IDs were switched? That does not make any sense to me. Oh my gosh, I see what happened. I put the cryoflux on the twist. Duh. Okay. Well, I'm surprised it's working at all then. Yep, you got it, Helen Croft. Yep, that's it. Duh. All right. Those bearings don't sound healthy. Yeah, no, I don't think they are. We're gonna try and resolve that somewhat today. So we'll see what we can do about that. But all right, solenoid not going down on there. They're just switched. So all right. Literally, let you out loud. It took me 30 seconds to realize no one heard me. Oh, that's great. See, Twitch just changed the ID. Should work fine. Yeah, I'll just leave it like that. We'll just keep that in mind. All right. So, yeah, this is just going to continue to not work. I can, again, hold down the solenoid. And now we're good. And then let it go. Bleh, dead. All right. So let's do this. And let's see if we can figure this out. Give me that back. And I will stop the software. Okay. Might as well turn those off too. Boom. Okay. So the solenoid. This is really complicated to get into here. Let me try and get some light in there, potentially. See how that goes. I'm not too sure if it'll actually go somewhere that's useful. So that's the bottom head. Yeah, solenoid, it is in the schematic, but I'm trying to just see it. That's the thing. It's way in there. Where'd my poker go? There it is. So, and this here is the solenoid. Way down in there. So getting to the cables on that is not possible without removing the PCB. And of course, the PCB has connectors going on all the sides, so I can't easily remove it and have it be usable. So I might be better off trying to figure out what is going on here. Because one of the first things I want to do is just see if there is a signal, a voltage even going to the solenoid. So I'm going to try and pull these out, figure out which one's going to there, because I think it's fed into this. Let me get that out of there. Okay, which one of these goes to the solenoid? It's this big chunky pair here, which is right on the end. Okay, so that goes to this, that. Okay, I can wiggle the solenoid cable with that. So the ones on the very outside of the bottom are for the solenoid. Okay. So what we're going to do is I'm going to try and sense off of those while it's running and see if the voltage level changes at all. So, okay. We have figured out, have we figured out if the solenoid is energized or if it's some intermediate component fault? Yeah, that's what we're doing immediately. See, does it draw a resistance reading? Yeah, I guess we can plug in and test that right now, actually, through there. Let's do that. I'm going to be using the Fluke because the 34401 is over there. Actually, I keep forgetting to do this. It's kind of precariously positioned, and I would like it to not be. So just put it down so it doesn't fall down. There we go. I don't have a lot of space for the 34401A right now, so I'd rather just use the Flukes at the moment. I think I have some cables I can put into the pins. Yeah, right there. Okay. See, hello, Starfarer. Having a light on here is both nice and awful. It is always in my way, but when I need it, it's really handy. Okay, since this is a custom cable, I will start by showing the resistance across them directly. Boom, actually there. So baseline, point something, barely any ohms. There we go. And now I will connect to these. Boom. 128 ohms. I think that's low enough that it's not an issue. That seems a little high to me. I don't know offhand. Let me try and look it up. Solenoid resistance. 120 ohms. At least it's not open, yeah. So it's not blown, that's for sure. So all right, let me do this. Let me try and put these into the back side. Just want to see if I can get them kind of stuck in there between the connector and the shell housing so that I can do a voltage measurement while it's running. I end up breaking this. I think my solid core wire is too thick. See, do you know that the chassis of the drive is cadmium coated, so you have to be careful not to breathe in any dust which comes off the coating? Cool. I hadn't thought that. No, that's aluminum. That's cadmium. That's, yeah. This no breathe good not be near. Yeah, that part's not great. Super pretty, not great to touch and breathe. Like, don't lick that. That's bad. I don't think I'm going to get those in there. Let me try and find some thinner breadboard jumper wires. What is cadmium? It's just a metal material. It has some corrosion resistance. That's why it's on the surface. but it also has some toxicity to it. So it's not something you really want to interact with. Wow, this is being a massive pain. I swear I've never had this much problem with DuPont connectors. Maybe it's because these wires are huge for the solenoid. Yeah, I can fit that easily into another one. Okay, so the connectors are just kind of enormous on this. Also, do I have that? Oh, did I measure the correct ones? Hold on. I don't think I did. Hold on. This is the solenoid. It's 128 ohms. Are they both? Does that go to like the front solenoid? No. Okay, so it's fine. It's that. All right. I'm just an idiot. Come on. It does not want to play ball with me. Okay, let's try something else here. See, that's why they cadmium sounds like Cadbury. Cadmium's toxic metal. Yes. Don't cross the streams. What is going to be my best option for this? If I could just get into the far one, then I could clip onto the close by one, I think, but this is really tough. Wow, that is so weird. Okay. We ban too much in the US. Oh, man. NiCad batteries. Yeah, they are still around. Okay, I might have it. Okay, I think that'll work. Now I just need to not pull those out and then get it on and test the voltage. So this will be high. This will be low. And it stayed in there, kind of, mostly, sort of, hopefully. Let's see what happens. Okay. Pardon flame bait, but lead make you, yeah. Okay, off, so we can turn it on. Boom. I get 3 volts there. Okay. We're getting a voltage reading. We're gonna try and image the disc and see if this changes. Start, yes, and no change in voltage. Ooh, that's not good. I wish this wasn't such a pain so I could try and measure the other side. Yeah, but I think we're gonna have to do that. I want to measure this drive. So So I'm gonna have to repeat all that. Yeah, I have to do it now. I have to, it's gonna be a pain. Measuring, yeah, measuring DC. Is it AC for a solenoid? I don't think so. Yeah, I don't think so. We're looking for, I guess it can be DC. Yeah, no, I'm not sure. Let me stop it. See if they get it's any change. I don't think so, so that's 0.4 millivolts, but we'll see on the other one. We'll compare the both of them. All right, I'll pop out the disc, shut it off, and try and do this whole thing again over there. Blech. Yeah, it's just the big motor. It's on the other side. This thing that's AC. Wish this was easier. Okay, that's that. On. That sounds bad. I think the floppy cable was in the fan. That's what it was. Okay. There we go. I believe these are 24 volt DC from what I was told. Yeah, after someone looked at it. Okay, so 3.7 volts with no disc. I'm gonna put in the disc. That should be the head lifted. So putting in a disc, closing it, changing the drive to drive 0, starting, and it should change 24 volts. So we're not getting 24 volts to the solenoid. Confirmed. Okay, stopping. Head should lift soon. Bingo. All right. So 3 volts at idle, 24 volts when run. Okay. So we're not getting voltage to the solenoid. We have confirmed. Bad driving transistor on the board? Potentially. Now we begin the fun of trying to diagnose that. Alrighty. Oh, man. So, how do we want to do this? Let me go back to the schematic here that I was sent to. So let me see what they were trying to tell me here. Yeah, schematic time for sure. So I was being told on page 65, there's apparently a logic flow chart, so we can take a look at that. Page 18, there's jumpers are intended to jump HA with ground. It will activate. Okay, so potentially that, but we'll look at page 80. Man, how many pages are there? It's like the very end. Let's see, where's the solenoid? Well, here's what I'm looking at. I gotta click in the right place. So I'm looking at the schematic here. I'm trying to figure out where the solenoid is. I wasn't showing the schematic initially because I was trying to look back at what I was told here. So, excuse me, it might be this page, head solenoid, right here. So, J1, J2, I think that is J2. Yeah, it's J2, A1, and B1. Okay, so that matches. That is where it is going. So Q14 controls 24 volts going into it. So where's Q14? I need to blow my nose for a moment. Okay. That load of stuff to turn on a magnet. Yeah. Check the transistor flyback that switches the solenoid. Well, we didn't get any voltage going to it, so if you're trying to think that it got zapped when the solenoid was open and closed, we're not getting anything right now, but I'm not sure. So yeah. Okay. Okay. Q14. That was it, right? Yeah. It's a 25C 1983 unit 555. Yeah, there is a 555 there for some reason. Cool. Oh, man. Let's see. Do we have 24 volt at all? We should. Both power supplies get the same voltage and one of them works. Or both power supplies. Both floppy drives get power from the same power supply and one of them works. We are getting 24 volts. That's confirmed. Okay, where's Q14? I think I only see one transistor. That's Q13. This one is Q. They blocked off the ref des with a via. Okay. Probably near the connector, but I'm not seeing it. That's Q11. That's a big boy. That's 13, 12, 11, 9, 8. I'm getting farther away. Where is it? See, door lock is also there. Ooh, yeah, that's nice. Oh, door lock. Oh, it probably can't open it. It can just keep you from being able to open it. Okay. Interesting. That makes more sense. Okay. It would have been cooler if it could just spit the disc out at you, but being able to prevent you from pulling the disc out makes way more sense. All right, found the 555. No, but why is that coded? That's weird. I should look for the 555. It'll probably be near that. That is U4J. What? That is a weird ref des. Huh. Alrighty. U4J. Oh, it's a grid. That's why. Oh, that's super weird. Okay. U4J. Okay, I found the 555. So where's the transistor? It's probably near that. But it's not. Huh, maybe I should just look on the schematic. All right. I would try to check on pin 1 of U3. U3. Oh, the U, okay, this, right here, U3JB? U3J9, JB, yeah, it's that, okay. That's like an op amp, probably. Yeah, it looks like it. The NAND gate below the 555, yeah. So that's connected to a diode. Okay. Oh, there should be a diode. There's a bunch of diodes. No, those are capacitors. What? Ooh, those are fancy glass capacitors. Doesn't go through that anywhere, right? No, okay. That all looks good over there. Oh! Fancy fours, strike again! That says Q11, except it doesn't. Just the diagonal part of the 4 has been scratched off. So that's actually Q14. That is the one I was looking for. Okay. Perfect. So we need to go, no, we need that back. Okay. So yeah, we probably want to check the output on that. That's going straight to it, right? That. There we are. That goes to there, A1. Where did that go? That's a touchpad. 24 volts up, so that should be raised to 24 volts. Why does it like flow back? Oh, because it controls the op amp. Okay. All right. Just trying to see if there's a touch point somewhere for that, but it doesn't look like it. Okay. So I don't even have a part number on it. Doesn't seem like it. I guess I'm gonna have to go based on the schematic, or you know what? I can just continuity test my way to figure out where pins are going. It goes to B1, which is, of course, on the bottom side. Okay. Okay. Excellent. One of those goes to VR8 diode, which is right there. So it's probably in the middle. Ah, right there. Okay. So it's base, collector, emitter. That makes sense. All right, I just realized you guys couldn't see what I was doing there. So if I go back to here, what I did is I connected to B1 on the connector there, and I can see it goes to there. So I believe that is the, no, that's the, is that the, I believe that's the emitter. It's the bottom one on the schematic. Then I can connect to the diode right there and see that it's right there. So that's the base. So yeah, that's probably the emitter. So that's the high side, but this has our switching going on, and we can connect to the diode to get that without having as much stuff around that we could potentially short against. So where's ground? I could probably just clamp onto the chassis to get ground, actually. There's 1 volt across that according to the multimeter. That's a little concerning. See, that NAND gate below the 555 is 30 volt open collector driver. The this thing, the U3. All right. Humid being, thank you for the gifted sub. Let's see. By the way, I'm using Google Translate to be able to write English, and also I'm not very familiar with electronics, but here's interested anyway. That's no problem. Let's see. Below the 5.5 with input 2 connected. Yeah. Yeah, you're saying right here, I think. I want to check what the base is though, so I'm gonna probe this going into there because that should be controlling it. Because yeah, right here should show whether or not it's trying to control the voltage coming down. So I could measure that right there. Let me do a real quick test to make sure chassis is connected to ground. Yeah, on the other side of the floppy connector, those are all ground. That's not just pure ground. Okay. Weird. How about the screws? Are they? No, because they're connected to the chassis. What? Okay, I'm gonna have to find a ground. That's okay. Weird. None of those caps are. That's strange too. Where's that ground at? To the left below the 555 on the schematic. I'm not sure what you're trying to reference there. It's below the 555. This? What about it? Oh, are you saying that I could get ground there? Is that U3J? I can't really tell. Yeah, U3J. But then it doesn't say what. It's probably A. Man, I hate monochrome schematics. They suck because you lose so much information. That has the input signal to the whole section. Oh, that thing does? It does go up there. I want to see what's at the base though. I want to work back from the actual signal and try and figure out where it drops out. We're testing the good drive. Yeah, we're going to test the good drive. Pin 1 and 2 is the input. Yeah, I want to test the good drive first. To see what it does when it's working correctly, and then we'll measure the bad drive next. Right now I'm just trying to find a ground though, so that I can reference my voltage here. Oh, how about these ones here that are labeled ground? That would be way too easy. Let's do that. Okay, that's connected. Have voltage. Let's go back to, not that, this. There's that. That's the solenoid control on. That's, oh, we're on continuity. So we're getting 11 volts, all right. Popping the disc in, clamping it down. Starting a read on, this is drive 0 now. Start. Yes. Goes up to 24. Okay, so that confirms that transistor can be used to measure the incoming signal. So we can stop that. Go to drive 1. Pop the disc into the other one, and I'm going to move these clamps. So there's a bunch of, well, the signal there, ground there, over volt? What? How's that possible? There we go, 11, okay. And then start. Okay, so we are not getting 24 volts into the base. Okay, so we can move farther back up. Let's get this turned off. And okay, so Yeah, I'm not sure what's going on with the potential argument in the comments, but we probably should knock that off. Okay. So, let's figure out where we want to go. Helen Croft, sounds like you have a good suggestion of where to go there. You want to measure this, I think, here. So 1 and 2 are the... Oh, both. Yeah, they're tied. That's super weird. Okay, so that's U3JA, I hope. It's a 7.5 something. Man, I really don't like monochrome schematics. Actually, black and white. That's it. The harsh bit black and white. That's the problem. Let's see. That signal controls everything. Also goes to the 555 input. Okay. So we'll check that because it also goes... Well, it's input. It's inverted output. Because it is really weird how wherever it's going, it is connected to a bunch of stuff. Whoops. That will help. I will open that up. Thank you for grabbing that. Okay, so yeah, this is it's got a side A and a side B, or a 1 and a 2. Yeah, that makes sense. Dual differential peripheral drivers. All right. So I got to figure out. Oh, I can just continuity test. That's right. I need to make some pokey probes at some point here. Oh, I guess I could just use the pokey probes that I own that go with this. That's how you do this. Duh. Okay. So the output 3, wait a minute, hold on. The output of this, we want to measure the input here because the output's connected to the ground side of the solenoid. So we probably want to measure the inputs there. So I need to figure out which side there is connected to what'll be the yellow wire here. That'll tell us which side it is. Yeah, so the input of that gate needs to change, yes. So what I'm gonna do is, give me a moment here, I'll plug this all in. What's this? Beep, beep, okay. So what I'm gonna do is I'm going to continuity test from the bottom side of the solenoid to the chip itself to figure out which side it is, because according to the data sheet there are 2 sides, so I need to figure out which it is, and then we can figure out what the inputs are after that. So let's go ahead and figure that out. It's pin 3? Can you tell which side it is? Oh, I guess, yeah, well, maybe it probably just should be, huh? So it'd be 1, 2, 3, boom. A little, or is it this? That's it. Okay, you're smarter than I am. All right. 1 and 2 is input. Okay, so these will be shorted. They're not. Why are they not? This is weird. So the output going to here is 3. No. What? Oh, they stop beeping. Come on. There. Okay, beep. What? 3. Oh, because it's right here, idiot. Okay, so that there, okay. And then these two legs should be connected. They are, oh my gosh. Okay, so we can measure one of those going in. They go off, there's a lot of stuff there. That's gonna be really hard to find. So we'll try and clamp onto one of those, measure that. Okay, and there. Voltage, 1 volt, I guess. Try and get this. There we are. I can see a reflection. Just turn this off. Now you can't see anything. Man. Oh, wait, hold on. That will work. Okay, we'll do that. So 1 volt, fire it up. It went lower, okay. So that's ground. I will bring up the software. We are testing drive 0. Start. Does it change? 3 volts. Okay. So we can test for 3.7 volts on the other drive. So I'll change over to drive 1. This is sketchy enough to clip onto. I'm going to turn it off when I change over. Gotta go, Soggy? All right. Hope everything works out well for you. I don't know if 3.3 volts is high enough. Since it's going into the 555 to control timing, it may not matter as much. So there's that. Looking at that chip a little closer here. I see some of that silver leg corrosion going on, like we saw that looked like the tin whiskers. So I actually got to talking on Twitter with Glitch about that, and apparently the Texas Instrument chips from this time has silver on them that is known to corrode. Yeah, the tin whiskers, the when we were looking at the MSI stuff and the unassembled kits, and we found the one that was like exploding out. So these have a little bit of darkening going on this particular chip that looks just like that. I don't know if I can get in there with the Nikon to macro that, but I will try. It is not going to be easy. Ooh, it's loosening. Let me change lenses. See, I would have expected something closer to 5 volts, higher than 4. Yeah, it does seem a little low, but it's working on that one, so eh. All right, see if I can get that. Okay, so that's the chip right there. This is the one we're going to be probing. You can see how the legs are slightly darkened. Maybe I can get that capacitor rotated a little out of the way there. So they don't seem too bad, but they got a little bit of it going on. Overall, the chip looks fine, though, as well. I don't see any issues with it, so it should be good. Yeah, I'm not concerned about it. So, see the driver chip, see anything above 2 volt is high. Okay, that's perfect then. Yeah, that looks okay enough. We'll see how it works out once we probe it. So I will be clipping onto here for signal, and then ground over there. So let's see what we can get. Turn it on. Goes low, okay. Turn that off. Disc in. Drive 1, start. Yes. We are getting nothing into that. Huh. Out of curiosity, I'm going to push down on it. So it's upstream from that. Man. Okay. We're going all over on the schematic. See HL jumper before it? Yeah. So whatever that is, here. So let me look for that. Huh. That is to bring it to other places, yeah. But so the thing is we've got, from here, it seems like it goes, well, actually not too many other places. So it's pulled high here by RN11, 4.7K. UE4 is what creates it. Yes, yeah, so let's find that, U4E, okay. So, where is that one? U4E is here. So fourth chip down, over here. Okay, I see it. That is pin 1. Okay. That'd be that. Alrighty. So we want pin 13. Oh yeah, what's going into that? Because yeah, it's directly connected. That is pulled. Oh, that's being given a specific voltage here. So, well, RA. It's connected to ground. Is that? Oh, that's just being pulled up. No, pulled. What is this down? If it's a jumper problem, it'll probably be X on the shunt block. Head load from drive select. Probably be X. Ow. That one's punched out on these. Let me just. Oh man, I made a mistake there. Okay, is that looking good? Yeah, that's fine. Let me just take a peek at that. Real quick like here. Let's do a dumb test. Let's continuity test across that jumper. Because it doesn't look punched out particularly well. And if I poked it with something and it pushed it back. Okay, beep. Okay, that's not shorting. Over here, I expect it to be the same. Yeah, not shorting. Okay. So that's as expected. If I go over 1, yeah, okay. So that's working as expected. All right, let's measure, what was that, 13 on the schematic? Yeah, is the input there? U4E13. All right, it's measured on the good drive. See what we get. It's going to be tricky to get onto there. I am tempted to actually use a probe from the 16500C. There's a, let's do this. So these things are actually just little clips. These go onto the probes and they go off to pretty much standard headers. So pin 13, yeah, mini grabber. So E4A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 goes to there. All right. Now I need a little extension so that I can actually get to the pin. Actually, you know what? I bet I can just clip onto it from there. Yeah, that'll work. And then ground. Okay. Yeah, that's still good. Try not to tweak the mini grabber super badly. All right. Let's see, even without working drive, we can find this out. Yeah, we can figure this out. We just have to figure out where the logic isn't being sent or changed. So, all right, bring this back. We're on drive 0. So, anyone have a quick recap what's going on? We are working through the different voltage rail or control signals for the head solenoid for the drives to figure out where it is not being activated. Okay, let's start. So 3.7, and this pulls low. So that should go low, it seems. All right. Stop. So where it stops is what's wrong, yes. All right, pop this out. Yeah, I'm gonna have to actually turn that off. This one's complicated again. Okay. High, good, that's what it should be. And this should pull low. Go to drive 1, start. Not going low, it's farther up yet still. Reposition so you can definitely see. Yep, all right, let's keep on trucking. Okay, so from here, we're gonna right keyboard. So U2D, it's a 3 input, cool. What is between this point and the floppy cable? Your adapter board takes care of the head load signal. What? What do you mean? The adapter board takes care of it. Jumper C is you'd... Unload, load. Head load driven by motor on signal. So that's there. Load the heads. Should I try changing the jumper to this from this? Cause yeah. Let's just do that. See what happens. That's fully in there. That's fully in there. Okay, yeah, I'm just gonna move this one over. So it should force the heads to be loaded all the time, I'm guessing. I'm gonna close these, and I just wanna see if it drops the head. Yeah, it should be the same both drives, so it doesn't make sense it would be this, but just for giggles, I wanna see what this does. I think we'll see the head drop here. No. Whoa. Let's not let that get into the fan. It would be really cool if they had any kind of shroud on it at all. Let's put a disc in. I'm curious. Drive 0, start. Yes. Kind of normal. All right, stop. Drive 1. So many jumpers gets a signal from anywhere. Yeah. I can't really easily show this one. I'm just gonna start it and tell you whether or not it works. Unsurprisingly, it did not drop the head, although there's no disc. Okay, hold on. It knows there's no disc. It's not dumb. This is like leaking black crud out of here, and I don't know what it is, and it's bothering me. Is there some kind of foam in here that's decaying? What gives? Start, continue. It just dropped the head. Low. It's working. What? I mean, there it goes. It's working. On the other drive, we're getting data. The jumper setting is identical. Does the other drive still work? Yes, it did. I tested that one just now. That was first. Yeah, that was easy. That was too easy. Hold on. Okay, let's do it. Let's go here. All right. So currently reading data. Stop. Drive. Change. Okay. Stop. Accessing. Why is the light on? There it goes. Okay. Start. Yes. Data. I moved the jumper over. I did this. I moved the jumper from here, head load on motor on signal, to load the heads here. That's all I did. And now it works. I mean, yeah, it worked before, I think. Maybe, I don't know. I mean, it is progress. Yeah, I don't know why it worked before. What is in that? Was it in that position the first time? I don't know. I don't think so, but I think at one point some of the jumpers had fallen off. Yeah, it's not impossible. Let me spend a little bit of time here trying to look at this. Twitch on the right keyboard would be helpful. Did I? Channel. How do I see my own videos? Where's that? Go here. Okay, videos. Bridge of jumper pins on the adapter with solder bridges so they can't fall off again. Yeah, really? Investigating 8-inch floppies. I think that one was the last one it definitely worked in. Why is this only 13 minutes long? 32 minutes. Why? What? Dropping. Oh, that's the end of the other stream. Okay. Hold on. Finishing 8-inch PSU. Okay, I think it's this. Right? Cool. Man, I am so good at Twitch streaming. Look at all these definitely working VODs that are good that you can watch. Here we go. 4 hours. Okay, these were scans. Did we get to scanning and preserving? No, that's not what I want. This is long. Here we go. I think I've got it now, Helen. Okay, okay, I'm looking at stuff. Do I hold it up to the camera? Please hold it up to the camera. That's my shirt. I'm looking at the manual right here. Okay, I've got cables. That's a cryoflux. That's the manual. Come on, I must have held it up to the camera nearby. Yes, I'm holding it in my hand. Hold it up to the camera. You know you want to. Do it. Boom. Okay, so HL looks like, yeah, it's off. That was it. It was off to the side. Can you do frame pixel? No, that's speed. Okay. Why does it have to tint the video as well? There we go. Yeah, it's definitely, it's not on what we currently have it on. Oh, you can't see it. Hold on there. I mean, you still can't see it because it keeps making it black. Let's see. Let's do this. No delay. No, stop this. Export. GIMP. Boom. Not on what I just set it to. It's set to the default there. I'm gonna rotate. 180. 180. There it is. Yeah, it was set to what I had it set to. So I've changed the jumper setting and now it's working. Why? You know what? Let's not look the gift horse in the mouth. Let's just Greaseweezle. Why not? I don't know. If it's gonna work, I'm not gonna tell it to not work. Okay. We have solved the problem by avoiding it entirely, I guess. Maybe. I don't know. Yeah, Greaseweezle time. Let's have some fun and play around with that. I gotta reassemble the drive here. Black dust. Yeah, you know what? Let's look at that. That's a good thing to, because I don't know what's going on with that and it's kind of bugging me. So here, maybe if I turn, you can see there's this stuff. I don't know what it's coming from. I can see it built up down to the bottom of the drive here too. It's like, it feels like a foam that's gone bad. See, so that's what the oil is for? I don't know. But where's it coming from? That's the thing. It's like maybe there was a soundproofing foam in here and it's completely decayed. Is that it right there? Yeah, soft landing for the latch, something like that. Let's see, does this... I think that might be it. It seems like it's in that area, so I think that's it. I just turned the drive off with the disc in there. Oops. It's been imaged and it is a known copy, so all right. Also, I'm now thinking the problem here is probably the lock solenoid preventing me, because if I reach in the back, I can pull it and immediately get it every single time. I think the solenoid is doing something, that it's not extended so it doesn't push correctly. So I think that it's doing its job, kind of. Yeah, the lock is stuck somehow. I don't know if maybe I could actuate it. Oh my gosh, there's a super sticky rubber thing on there that's awful. Bleh. So that could be causing 100% of my issue. Ew. But on the other one, it works when it's off. On this one, it doesn't. All right, I can definitely see what the problem is here. This can be visualized pretty easily. So the lock works. When I push the black thing, you'll see the whole thing rotates. But if I pull on the solenoid, it catches on the top and then brings the plastic with it. Over here, if I pull on the solenoid, it just passes the plastic. So, yeah, you know what it might be? That yellow disc on there that stays behind on the black plastic might be supposed to be glued to the solenoid. So yeah, this just isn't going to work. So how have I ever gotten it to work? Yeah, if I push up on the solenoid, then the lock it. Ooh, that's so weird. That yellow might be a hole for screw. I can't tell. There may be only 2 screws holding the front on. Let's try and take it off. We have, oh, this is the one that's glued in place. We were limited in how much we can move it, but we can try to remove the front face and see if we can get that out. So on the top, we can see there are 2 screws in there that hold it together. So I'm going to see if I can pull those off and get the whole plastic front, because it's loose on the bottom and it's solid on the top. So Yeah, I'll have to release this as well. If it works, fix it until it's not. Yeah, but it doesn't work. So the problem is the lock solenoid on here seems bad. That's what seems like it's going on. So I've identified an additional problem that I couldn't figure out how to resolve before. Now I may have an idea on how to resolve it. But I need to look at it first. There's a mechanical issue with the lock solenoid. Wow, these screws are super tight. Holy moly. Yeah, this is a different problem I could potentially try and ignore, especially now that I know I can use the other drive. But I would rather not. I would rather be able to say that the whole thing works. I don't know that I'm going to be able to fix this once I get in here, but I want to be able to understand the problem at a minimum. Let's go here. Start with the screws that hold the bezel to the frame. I will, but this is going to have to go one way or another, so I'd just like to get it right now. I'm thinking about it. There we go. Because this is held in place. It can't come out, so it's part of the bezel. Now we can take the bezel screws off, which are much looser. Maybe there's another jumper. Yeah, a jumper to fix the mechanical issues. All right, see if this releases the whole front. I think it's going to. Huh? Ah, okay. So, what do we have going on here? Oh, this is disgusting, this brown. Ugh, the tool just sinks down into it. Oh, now it's pretending like it works. You're not fooling me. You don't work. So that is a plastic thing, and I just pushed it out. So that's some kind of rubber stopper, I think. I wish I hadn't done that, because now it's going to be really hard to get back in. And there it goes. Okay, so that was this. This is just some... Oh, it's super gone. Uh-oh. It did the tweezer pinch shoot. Oh, no. Yeah, I don't think I'm ever going to see that thing again. Pretty sure it bounced off of the back of the oscilloscope here and then shot off into... anywhere. I don't know where it went. It was so light and it got so much instant inertia from the tweezers. Oh, that sucks. Okay. It wasn't needed, so not a big loss. Yeah, I don't see where it could have gone. All right. That is frustrating. Pinged off to Foreverland. Yeah. I prefer the older style VARs. Much prefer the older style. So let's see. If I pull this, it's grabbing that. It grabs it by the lip. So... yeah, I think what's happening is this stupid sticky goo circle is jamming this. So should I just remove this? Because I think that's 100% of my problem. Because this thing is seriously, seriously gross. Like, just press into it and just, yeah, it's liquid. I think I should remove that. I don't know what the repercussions will be, but I don't think I'm going to miss having it gone, and it might actually work without it. I think the solenoid will, yeah, you'll probably just find it when you step on it. Yeah, really. Yeah, I think I'm just going to see if I can... Oh, it's so gross. I think this should be rubber. Yeah, oh, that's awful. Blech. All right, so there's that thing. I could actually print a new one. It might not need to be soft. There's a spring there. What is the point? Will it go down too far? Oh, it's jamming. That horrible goo got onto the shaft and down into the solenoid. Oh. So the spring can't push it back up. The solenoid just gets pulled down. Oh, that's awful. Oh, no. So, this is really hard to film because I can't move this out of here because, well, I guess I can just release this. That might actually... One moment. If I do this... Come on, let go. There we go. All right. So you get 2 screws that hold. Yes, that should work. I could probably get this off. But what I was trying to show here is that the goo is on the shaft. It is liquefied into the solenoid. And I'm gonna have to like get it out and clean it. So yeah, I think I am gonna have to remove all that. Well, on the plus side, I think it's actually gonna fix it. Isopropanol? Yeah, that's what I'm thinking. Okay, so we can take out a whole bunch of stuff here. Looks like those 2 screws, I don't even need to. Let's just flip it around. There we are. Oh, hello. Perfect. Okay, so there's that. And I just need to take this off. Oh, yeah, look at that. Look at that horrible brown goo. Yeah, perfect. I probably just can wipe this off with a paper towel. If I can find one. One from my lunch today. Yeah, we'll get some isopropanol in this. I think I can use cheap stuff, 70% here. Feels like it was made to be serviced? Probably. Tiki Motel, I will change the keyboard in a moment here. Let me just get this figured out because I'm kind of real into this. It wasn't made to last though with the brown stuff on it. Oh yeah, that's so much better. I don't know if there's any inside that I need to worry about. I don't think so. Without the spring on it. Oh. Yes. Way better. Okay. The spring has some of it on there too, but if I get too aggressive with that, I will deform the spring. So if removing the sticky stuff fixes it, maybe also remove it on the other drive. Yeah, I think I should. That one's also doing the weird rubber belt molding thing, so I think I should really remove it from that one. Oh, yeah, that's the stuff. Okay. So we're going to do that. Pop it back here, and it does catch. Hopefully it extends up a little more when it's running. But yeah, that's way, way better. If it doesn't extend up enough, then I could probably stretch the spring a little bit to get it the rest of the way there. Yeah, I think that's going to work. So, okay, let's put this back in here. What is that? Is that just paper? Some kind of plastic thing? I don't know what that is. Don't think it's needed. How does this work? Is it really wide? It is really wide washers. Okay, I think these are held in like super wide washers. What is this? I don't feel like it's going down as far as it should. Let's see. Might have been, could have been disintegrated. Yeah. Oh man. Okay. What was the part? Was the part you've lost important? I don't think so. Excuse me. I think it was just a little rubber cap or plastic cap to keep the lip there from being broken. So I don't think I lost anything critical. These springs are driving me nuts though. Does not want to go. Oh, is the button the problem? The button is the problem. Oh my gosh, I'm an idiot. Okay. Rubber goop might be a silencer for the pin? Possibly, yeah. Okay, if this works like I think it will now, it should move the stepper every time. Yeah. There we go. Got out once. We'll see. Here's what I'm going to do. Before I put this all back together, I'm going to take off the front on this one as well so we can compare. And I'm going to try and not lose the thing on this one. Because I think the one over here is even grosser. All right, get these free while I'm thinking about it. Okay. Yeah. So this one, it's starting to form the little mold dots on it. So that's cool. Now that I know that I can just tear the whole thing apart, I'm going to remove the shaft from, or piston, however you want to think of it, from the solenoid before I rip off the goo. That way it hopefully doesn't smear as much all over the shaft, whatever it is. I don't know what the term is. See, forgive me for butting in, but can anyone tell you how? Probably Adrian Black could. He got 8-inch drive working in PC. Never shipped with those. Let's see. I suddenly 8-inch drive my phone. Ooh, I put that in the wrong one. Get that back out. There we go. Let's see. Don't lose the small thingy this time. Yeah, I'm not touching it. There we are. Yeah, so that's what I lost on the other one. It's just a little spacer, I think. It might even be like a dampener for it. Yeah, so this I can just pull out, and then we can get the disgusting spotty mold rubber wheel. Oh, God, that thing is awful. That is the worst. Gross. All right, there is a small amount of residue. I'm just going to run it through the paper towel. That's propanol, just to be sure. Because, yeah, I don't want to have to do this again. Let's see. You have the machine that goes big. All right, there we go. Spring. Okay. And there we are. That one feels a lot more like it wants to latch than that one does. I think I want to stretch the spring out on this one a little. Although that's going to be hard now that it's in there. I don't know. We'll just leave it. It'll probably work. It doesn't have the horrible thing trying to pull against it now, so it should probably be fine. Okay. Oh, now I see how those springs work. I did not get that right over there. All right, I will stretch the push button springs out a little more. Yeah, I'll get it. I'll do it. I'll get this figured out. Let's see, wondering if a rubber dome from a laptop would work for the part you just lost. I don't think I need it at all. It's definitely 100% something where I can say you could actually 3D print that. It is just a little hard piece of plastic. I could even just put a dab of hot glue in there, I bet, and it would also work. It is not a critical thing. It's oh, the rubber tire I just took off. I could try and find a replacement. I don't particularly care to. I don't think it's important. I don't think it's worth worrying about. So, oh, this one's loose too. Now it works. Maybe it's supposed to be loose and then it lifts. Okay, I think it lifts. All right, let's just try this. Let's just put it back together as is. See what happens. Worst case, I know it's not going to be too difficult to take it apart and fix it again. So, yeah. Let's see, it's not like we control the lock. We have the cryoflex. Yeah, I don't think we can. All right, pop these back on. That feels a lot more like it's going to work. I think that was a worthwhile exploration. And additionally, I know I need to do this to the other two drives I have as well. So I should not play with the buttons a whole bunch until I get the drives open and take out that stupid rubber plug. get in there right? Ooh, that's a thing. Okay, there are disc guides. You have to make sure you get aligned correctly. So if the drive's working, we can now take a look at the CompuPro. Right now, my main focus is on getting discs imaged. And for today's stream, our next thing is going to be taking a look at the Greaseweezle. I want to try and actually get some discs imaged using that as the open source alternative to the CryoFlex. Because CryoFlex is all proprietary and pretty expensive too. So I would like to try the more affordable Greaseweezle and see how that works out. Man, there are a lot of, if you're not paying attention, you just build your own CryoFlex. You can do that. The design is open source. I mean, they still have their really stringent restrictions on software. Yeah, the CryoFlex is expensive. I tried not to hype it up too much in the last video I did because I didn't want people like thinking, oh, this is the best way to image floppy disks. It's just, and I tried to point out I'm gonna be getting a Greaseweezle, so yeah. You can buy a Greaseweezle. I did not make this, so yeah, you can do that. Is Greaseweezle read-only? No, it actually has, we're gonna have to take this apart and look at it first because it has jumpers for write blocking just like the CryoFlex does. So, no, it can write as well. Okay, I really need this to just like hold right there. I'll screw this in. There we go, finally. I don't think the Greaseweezle is an open source clone of the CryoFlex. I think it's more that they kind of do the same thing. But I don't believe they share any common design because the CryoFlex people probably wouldn't be too thrilled with that. Wonder where the name Greaseweezle comes from? I think it has origins with the Catweazle. But I don't know where that name comes from. Let's see, I have some spare CryoFlex PCBs left over from my own redesign that includes the power supply. Ooh, that is fancy. Say coming late, is he still fixing the drives? Yes, I am, George Tech. Well, actually, we're just reassembling the drives. We kind of have them solved. We're gonna do one more test before we call it done, but I believe that all of the problems with the drives have been found and resolved at this point. Well, okay, that's not 100% true. We bypassed whatever weird stuff is going on with the head solenoid. We didn't actually fix it, so yeah. Yeah, Greaseweezle is a pun on the name Catweazle, yeah. Yeah, it was the PCI one. Yeah, I didn't know that you could actually... I thought that the Greaseweezle was the PCI one, which is its really dumb name. Because of its really dumb name, I should say. Oh, that... Yeah, that one's good. Okay. That seems... Oh, where is that hitting? Is that where the pad is supposed to be? That it is decaying? Yeah, I think that's it. Yeah, I don't think the pad is decayed as bad on that side. Okay. See, wasn't one of the spindle belts going bad? I don't think so. No, I think it was just that the one disc was supposed to be 300 RPM and then this thing was spinning at 360. I think that's what was going on. I don't think that there's a problem with the belt. Because the belts are the fabric kind. So they don't go bad as quickly, I should say. Okay, let's try this. Oh, yes. That is so much better. That one has never worked that reliably. That is a massive improvement. Okay. Let's see. Should I make a chain drive spindle? Yeah, very snappy. That's the way it should be. Yes. Okay, we've made some really good improvements here, I think. I don't like how this drive was solved by just changing a jumper on there, but oh well. I mean, I don't know. So, I do need to... We should try these one more before we put it all back together. We'll try them one more time, just to verify everything's good. I want to see how the headlock operates, if it does do anything. I don't remember it actually making sounds, so I'm not sure. But I just want to make sure that the drives will actually work if I put them back together now. Why does this not want to plug in? There we go. That sounds awful, but okay. Let's see. Came across PCIe adapter, gives you 2 PCI slots. Spent half an hour trying to think of PCI cards I would use with it. I can't think of any PCI cards other than maybe SCSI controllers, just to get some old ones, because they do work better with some things. All right, let's make sure the floppy cable isn't in the fan. Nope, it's not. Okay, CryoFlux is on. Let's turn that on. Pop a disc in there. Oh yeah, that's so much better. Oh yes, that's the way it should be. All right, let's test reading. So drive 0, start. I'll show you guys the capture. Yes, boom, boom. And it's just going. This does not work. The lock is successful. So the headlock actually works now. I had not experienced that before. Yeah, the front is on straight. This one's just slightly crooked. Oh, I need to do a change keyboard. Here, Tiki Motel, you redeemed a change keyboard, which means that I'm going to stop using this Keychron K8, which is frustrating. And I'm actually going to redo the Cherry G84 here, because I'm also going to stop using my Corsair Harpoon RGB because I found a correct functional PS2 adapter, and now I can use both the trackball and the keyboard. So there you are. There is a change, and yeah. Well, woo. But yes, this drive is working correctly. Yeah. So yeah, that's excellent. Okay, let's see here. Oh, it's just got like 5 more sectors to go. I'll just let it finish. And then we'll swap it over to this. That's okay. Done. Light off. Oh, that's so cool. That is cool. Okay, into that. Can eject. Excellent. Latch. Drive 1. Test. Go. Light on. Heads dropped. Getting data. Cannot eject. Yeah. Sweet. All right, that's cool. We don't need to let it run the whole image. I can't just eject the disk now, and that's how it should be, which is kind of funny. I didn't realize that this whole time. So light off. What? Light. Boom. Release. Bingo. Oh, that's so fancy. All right. Let's go ahead and reassemble this, because it is working. Awesome. You know what? I think I'm going to give you this view for a moment, because there's a lot of big stuff I have to move here, and this will just be a little bit easier. So, oh yeah, this is the GoPro 6, like I mentioned, and I adjusted the lens so that it gives a much better view here. So, yeah, that's what this looks like. So, let's see, just imagine modern PC, original IBM MDA card. Yeah. Oh, this is so nice. I'm just going to unplug all the power connectors so I can put this back in without having to worry about that. Now the floppy cable's loose. Oh yeah, I did unstick the floppy cable from the case. This black strip here is the piece of tape that was holding it in. I'd mentioned that at one point. I ended up deciding just take it off. It's not worth having it and messing around with that. So, okay. There's the drives. Now I need to tip this over, and I need to make sure I'll hold up that one. There we are. Cable's good. Wow, there's a lot of dust under that cable. Jeez. All right, I'm gonna let this flop. Oh man. Blue plastic shot into the drive. Hopefully it'll just fall through. This connector is super brittle. It keeps shredding every time I touch it. It's frustrating. I may have to replace it at some point. How much power does a drive like this consume? That is a good question. I have no idea. Oh, actually, no, that's not true. I did load tests on it. It's about 3 amps at 12 and 24 volts combined. So probably about barely anything coming into it from the wall. So it's really very low, actually. I forgot I had to do the load testing. That tells me exactly how much power it uses. Okay, I'm going to get the power supply section dropped onto here now. See, if you have some spare 8-inch drives, put a single one with a power supply in a smaller case, compact desk unit. So what I'm actually currently thinking is that I might try and do a setup where I have one of these two cases, or one of these cases, but replace one of the 8-inch drives with a 3.5. Like, is a 3.5, would it fit vertically next to that? Because it seems like it would. Yeah, so what I could do is I could take out one 80 track and then put, wow, 2 3.5s and an 80 track, or I take out one 8-inch, put an 80 track and a 40 track in the case and a 3.5. That way I can have everything in one case and I could just use the original case. So I'll have to make a slightly custom thing, but then I'll have all of the floppy drives that I could possibly want in a single unit. Yeah, Swiss Army disk drive, basically. And then I could use the floppy switchboard that I designed that I showed a while ago in my test bench to control which ones are active or not. Or I'll just, you know what's more likely? I'll just finish up the disk imaging of the 8-inch discs like this and then never need to touch an 8-inch drive again. That's probably more likely. Let's see. VARs, the 3 amps was at the DC side. So that's more like, do 3 amps times 24 volts, worst case. It's really not that much. Floppy switcher? Yeah, so it's a really basic thing that I designed. It just disconnects the drive select IDs and allows you to reroute it so that you can connect actually an arbitrary number of floppy drives to a single system. But the way I have it set up is it gives you 2 connectors that you can enable or disable the drive IDs going to. I have to make a video about it at some point. It was in progress, and then I got derailed by some other projects, and then I got kicked out of my house. So, you know, there are a lot of projects that were in flux, and then I get kicked out of my house. That part, you know, kind of hurts your productivity. Okay. There's that. Don't forget the grease. Ooh, yes. That part's hard to test, but you know what? You're right. So I have some silicone grease here, and I think I can put it right here. So let's go to this camera angle here. So if we pull the head here, we can see this spins just slightly. Maybe you can't. There you go. You can see that spins. So that is the end of the shaft. And I think if I put a little bit of grease in there with this needle applicator, it'll probably wick down into where it needs to go. So I'm going to do that. I'm going to try and move it back and forth a bit. Hopefully it gets down into where it needs to be. Yeah, I was renting. Oh, it wasn't just renting and they didn't renew. It was more complicated, but month to month, and then they saw dollar signs when the Arizona housing market went insane and just decided to sell the house. That was what happened. So, yeah. Fun. So there was literally no warning. It was just 1 month, get out. That was it. Oh, yeah, gross. Black crud. This is separate motor DC. Yeah. Yeah, this part's DC. Yeah, it actually says 24 volts on it. Yeah, it's only this that is AC, and that motor is on the other side. You'll see it when I get these screwed in and then flip the whole thing over. I really like the smell of this silicone 3-in-1 oil. It is a pleasing smell to me. Let's go back to this. Oh, I left all the cables loose too on this. Here, let me reclasp those. That one's a little trickier. Yeah, like that. Okay, this one wasn't touched. All right, that's all good. Completely ready now. Sad that property is expensive to own. Yeah, it only gets worse. Let's see, turn it on for wick, top bushing, unaffected. Yes. So on Tonomec, I was actually massaging the heads back and forth to try and get it to move a little bit. You're not supposed to run it upside down, but I bet that that's only for that head solenoid. So if I run it for a little bit upside down to just spin the... oh, no, I would have to seek the heads back and forth a whole bunch, actually. That would be... I could calibrate the drives a couple of times to get them to move the heads back and forth. I could do that. See, imagine relapsing the spindle motor with... replacing, yeah, that would be nice to have it all BDC. It really, really would be. Ooh, that's, you know what? You just made me realize something. Maybe the all floppy drives in one thing is not going to happen, because there's no 5 volts in here. So that complicates it. There's AC and there's plenty of 24 volt, so I could probably just regulate it from something, but I'm not really feeling it. Maybe just separate projects. I still want to 3D print a case to put the other floppy drives into, so I'll probably just do that. Just get cheap DC. Yeah, 5 from 24. Yeah, I could. You know what I can do? I will go ahead and continue on with my project of making a, I wanted to do a case, or I was actually looking into proto case, getting a case manufactured that was stamped steel, kind of like this is, to do this, but a box that holds the 2 5 1/4 and then 1 3 1/2, something like that. I'm probably gonna 3D print it. I could just design it to fit within an 8-inch drive. And then if I want to integrate it into something like this, I could. Or if I want to use it separately, I can as well. So I just have to design it to fit the form factor of an 8-inch floppy drive. That's all. So that should be totally viable because there was free space all around everything when I held it all up to size it. So yeah, we can do both. I'm going to switch over to my better driver here. Let's see, you should already have 5 volt in there. I think it's 12 volt. J metal, this runs off of AC 12, 24 and 12 volts. There is no 5 volt rail in here at all on mine. There might be on some other 8-inch drives, but not on this one. Or wait, oh no, you're right. It's 12 volts it's missing because I have it literally written right there on the whiteboard. Okay, so it's 12 that's missing. Okay. It still doesn't really matter. I can, I'll just, yeah, I'm probably not going to do that because I don't think I'm going to need to continuously do 8-inch discs all the time. But if I do, then we'll take a look at it. See, but the TTL chips need 5 volt. Yeah, I think I was wrong. Okay, that got pulled up. Could this be tightened a little with adding some support? All right. That is my first call ever to that phone number. Huh. Okay, that's a bit frustrating that got out somehow. Okay. What am I doing here? I'm plugging this all in, and then we're gonna seek the heads back and forth a little bit. So I gotta power it. I gotta get everything connected here. Let's see. The 8-inch drives, yeah, see, making a weird bell sound, yeah. So, okay, let's go to this view here. Scammers just dial every number. Hopefully that's what it was, because that number has only been given out to a few individuals. So funny story. I messed up. These, whoop, they go the other way. Let's do this. And I can't just remove the cable to do it because I glued it to one of the drives because it's bad. So I actually have to do this. Okay. Oops. Yep. Alrighty. You know what? Let's go with this view. Let's go with something different here. Oh, man. Yeah. Oh, man. All right. See, where are we at? 2.5 hours? Yeah, 50-50 chance unlucky? Yeah, it's really weird because the cable felt like it was really well laid out for that, but no. And I haven't swapped it between the two drives, so that's weird. Got one car accident, and my reply was, yes, I was in an accident. Yes, I caused this accident. Yes, I meant to crash my car into his. Also needs an LS120 in the big drive box. That would be doable, because I would have space for 2 3-inch, or 3.5. Not sure how I would interface it. Could I just get a USB IDE interface? I'm gonna have to put a hub inside of this thing. That I'd end up making this monster. Should I have a Lisa floppy drive? I have a Lisa, and it does not have the weird floppy drive. Those are very rare, even in Lisas. Yeah, USB IDE works? All right. Also, zip drive. Now, I draw on the line at zip drive. We don't do zip here, okay? It's all LS120. So, how does this go? I think, ooh, hold on here. Okay. I think I need to do one of these. Whoop. There we go. Now, the folds make sense both ways. So frustrating. That's actually even a little tighter than the other way. All right. There we go. Weird itch. And that aligns it with that whole nonsense. All right. Blech. Okay. Put the hood back down. Get it screwed in again. Boop. Okay. Sensible folds is my Ben 5 volts cover band. Coder Joe, what about SideQuest? The SideQuest is 5 1/4 inch, so it's a little hard to fit in there. But I do actually have a functional SideQuest drive. I booted that keyboard off of it, actually. Also, hello, Coder Joe, since it's your first time chatting. I have a Bernoulli drive as well, but I don't have media. Yeah, stream looping, I've seen this part already. That's why I'm going with the different camera angle, trying to mix it up slightly. Oh yeah, wrong driver. Put a 1/2-inch tape drive in there as well. That'll be a little hard. I have LTO, is that 1/2-inch? We can do that. I don't know how big this mythical floppy box that's supposed to save me space is gonna be though. I mean, I feel like we're up to about here now. Humid being, thank you for the gift sub. Really, what happened to that? So the VAIO, I'm actually, this is a thought that I've had, all right? So I'm trying to set up corners of different computers. I have my Windows XP PC right there. I kind of really badly want to have somewhere to put the VAIO because it's really cool, but it's caught between 2 times. It's too late to be a good Windows 98 computer, even though that's what it is, and it's too early to be a usable Windows XP computer because it's not going to be able to do anything with that Rage 128 or whatever it had. So, unfortunately, as cool and awesome as it is, it's just, it's out of place. It's out of time. So, I don't really have anywhere that I can set it up and dedicate the space to use it with, because anytime I need to do like a Windows 98 thing, it's not the best computer for that, and then for a Windows XP thing, it's also not the best computer for that. So it's just hard to dedicate somewhere for it. Yeah. Windows ME PC, there is nothing you can do on ME that you can't do on Windows 98. Better. There's no follow-up, that's just how it is. Remind me what connection the graphics card has in it. Motherboard. It is on board, so it can't be replaced. Plebonian user, I think. Hello, since it's your first time chatting. All of the non-vintage computers in here run Linux, so yeah, and hopefully soon one of the vintage computers will be, but I have a lot of work to do on that still. Ben Gizmo, I also have the PC cassette drive interface. I actually bought it before RMC made his video about it, and then I was like, well, I can't make that video now because he already did. His is in much better condition. It was a better video than I could have done anyway because he had the box and everything. I just had the bare drive. So it's better that he did it with what he had. Okay, now I can get the power connectors plugged back in, get the floppy interface cable where it needs to be. Then we can power it and seek the heads back and forth a couple of times upside down to make sure the oil I put in there 3 years ago now, it gets into all the places it needs to be. And then I might, I don't know. I'm tempted to try and remove these covers because I think, oh, no, we're not removing that. That's a pain. Screw. Pass, never mind. Unless that one screw is it, and I don't think it is. Yeah, I was gonna say maybe try and drip it down that, but I actually really don't see a way to do that. So nope, pass. Not doing that. So we'll flip it upside down after connecting all the power, and then seek the heads back and forth, and that'll be as much as we can do for the oil. Oh yeah, these are the AC motors in this. They look the most serious for sure. So also just for grins and giggles here, oh, these move so much more freely than when I first started. That is excellent. Oh yeah, all right. We need a Windows version poll. It's 98, that's it, that's the winner. Best Windows is 98. See, oh wait, tech tangents. What about installing a version of Windows Server on the VAIO? Well, the other thing about the VAIO is that it's so original. I really don't want to mess with it. That's what makes it really cool to me, is how complete it is. Like if I just had the VAIO computer itself, then you know maybe I'd mess with like different operating systems or something. But it's so good as it is that I really don't want to monkey with it. So I just kind of want to leave it. But unfortunately, leaving it alone means leaving it alone. That's the downside. All right, I got to get this ribbon cable connector in here. So let's work on that. Boop. All right. These screws are oh, they're in the lid of my driver. These are a pain to get on because it's actually easier. Put it on like that, and then feed this down and in and around. And then that's one. But the second one doesn't want to cooperate, and I gotta swap bits. Let's see, this person here knows what's up. Best Windows is DOS 622. You got your poll? All right, let's do this. It's 98. Oh, awesome. I agree with this poll. There we go. Yeah. I am in agreement with that poll. It's a completely fair poll. You can choose from any of the options you want in that poll. Alpaca Attack, hello, so this is your first time chatting. All right, that's attached. Power cables are all attached. I didn't end up taking that off. Okay, so this can be flipped over, seek the heads a bit, and then it's done. We can put the top case back on and try out the Greaseweezle. Actually, let's just leave it open. Why not? There's no reason to make you guys sit through that. There are so many screws on the sides. Seriously, there's like 3 in the back here, then it connects into the 2 there, and then 1 there, and then 1 up there. It takes forever to put the shell back on. It's really not worth it to do on camera. So I am flipping this over. Oh my gosh, look at all of this. This, blech, so much felt pad. Ugh. Human being, thank you for the gifted sub. Oh man, you guys like 98 almost as much as I do. That's awesome. All right. Plug, this in. That's, there's that bit that fell off, so I don't have to worry about that getting into something. Oh, this feels wrong to run this upside down. I know I shouldn't. Let's see how much calamity it makes. Well, it's really quiet. Oh, it's just because the drives are facing away. Yeah, it should be all good. Okay. Laptop. I said, let me click here. Laptop. Alrighty. Drive 0. Calibrate. Yes. The head was far away. I didn't like that. Took too long to home. Calibrate. Yes. We'll run each one 3 times. Okay. 2. Might as well go here. And 3. Next drive. Calibrate. Boom, boom. Failed because it was not homed. Calibrate and go. All right, one more. And final time. There we go. We are done working on the floppy drives. So, I'm going to shut it off. And let's try out the Greaseweezle, because that is our next objective here. Just going to unplug CryoFlux and that. Flip this whole thing on over. And let's get into this. Mission accomplished, yeah. Good thing you grease up the drives before, yeah. So that it can be compatible with the Greaseweezle. Yes, finally the Weasel. Yeah, only took 2 hours 30 minutes to fix. It was worth it. We did some extra stuff like the latches. We didn't have to do those, but I think that was very, very worthwhile because now both of them work really well. Didn't get to this, but that's fine, whatever. I'd have to do a lot more work on that. So yeah, I'm pretty happy with all of this. So Greaseweezle. Let's see. So this is it. And there we go. Yeah, it's got a USB connector and a floppy connector. I mean, what more do you need? Let's go ahead and get this thing open because I want to take a look at what the jumpers are. I think this is actually going to fit here. Yeah, coincidentally, I happen to have an Allen wrench that's the correct size. Let's see. Is there a Weasel themed version of Ubuntu version? Most likely. Okay. Boom. So this board is the Greaseweezle itself. Let me go ahead and turn this light on. What is blocking? Why is there a big old shadow over here? Is it this? Is that? I am not sure what is causing the shadow, although I've rotated this around so much the power cable's all kinds of caught up in it. Let's just do this. Okay. But yeah, so this is the Greaseweezle board. It is going to be very similar to the CryoFlux. So yeah, not a lot to really go over. What I wanted to look at here, if I bring up the Greaseweezle repository. So here it is talking about jumper configurations. It has a WRT ENA. From factory, these pins are jumpered to allow your Greaseweezle to write a disc. They're labeled over here. So it's these two. That is the write enable. For now, I'm actually going to disconnect that. Because I'm trying to archive discs. I want to leave that. You know what I can do here, actually? I've already made a solution for this, and I think I've got it in this, and I'm not using it currently. It's similar to that, but not that. Ooh, it's real close to that, but it's not that. Glad to see that's in there. Looking for that. I really thought I had another one. I might be able to make this work. So something like this. Oh, you can't see squat. One moment. So this is just a header with a 3-position switch soldered onto it. And I want to just put this on there. So I will need to modify this. You know, I'll do this later. We'll keep this in mind because we can do this and then bend it over and then access it from the side of the case, because right now we can't modify this without removing the case, which is slightly a pain. I just thought I had one of these that was already right angle that I wasn't using. But it looks like not. So I will have to just deal with it. Let's see. Let's try to see if there's any like bonus jumpers, because some people have come up with a way of doing some stuff where you can put a speaker on there and make buzz, buzz sounds come from this. So yeah. Weird it didn't use a Phillips screw. Yeah, some of them are Phillips, like those. Well, actually, those are captive nut, and then that's also hex. It's really easy to get cheap hex bolt kits online, so that might be why. I don't know why. Oh, Jout gotta go? All right, I'll see you later. At least you got to see the conclusion to the drives themselves, so. But yeah, I wanted to disconnect that. I left the Arctic Silver out. Ooh, yeah. Okay. So there's the write enable and firmware update mode. We don't want to touch that. I think those are the only jumpers, actually. Yeah, so just leave that disconnected. That's all I need to do. Put this back together. Is this mirrorable? Smart. Well designed. So now we can connect this to stuff and not have to worry. Okay. I don't think I've seen a single one of you make the Barney reference to this color scheme, and I'm disappointed. All right. Let's get this plugged in here. Oh, now I see how I messed it up. Okay, that's weird with the oh, that's awesome, Helen Croft. Or is it just your entire city is like renewable and they pay you to consume electricity because they overproduce, or do you have like solar or something? You like the colors? I like the colors too, Cody, so, you know, don't feel bad. Okay. I guess plug it in. Boom. Let's see what happens. We have one LED that's kind of in the middle somewhere. It's on the other side of the jumper, so I can't really see it. Yeah. Joker 67 vibe. I think that's actually what it's trying to go for. But I think maybe Riddler. So there's that. There's this. Yeah, I guess let's turn this on. So let's see what we can do here. So we're going to use the command line versions of this first. So no more DTC. We're going to need one of these, and that's pretty much it. So let's do this and try and figure out how this works. Although it looks like I'm gonna have to move the laptop over slightly first here. Bingo. Okay. I put a lot of time into this morning. I kind of got the stuff figured out on how the streaming is working. Mostly because I had to figure it out for the split view that we have had no use for today, because I can now independently control the views. So if you want like top down to see the drives, and then we have maybe something going on this, we could actually do that now. So that's handy. And then I could hide or show the laptop off to the side there too. So yeah, trying to continue evolving this, make it a little more useful. See, Greasing the Weasel, split screen multiplayer, yeah, with the map in the middle. Greasing the Weasel is, you know, what you do to, you know, try and capture a Pauly Shore. Let's see. How's that circuit breaker switch feeling? Not great. It feels kind of weak when you push it up. I don't like it. But anyway, GW, it's not the Goodwill command, it's the Greaseweezle command. So this is what we have to run everything through, and it looks like it's going to obey 80 columns, so I'm going to try and get us close to that. So we can do info, so GW info. Let's verify that it's recognizing it, and it is. Oh, there's a firmware update. Okay, now I'm disappointed that we jumpered it because I don't think it'll work. GW update. Downloading, updating. Oh, okay, I didn't have to do a jumper. All right. Yeah, I agree, Devin. It sucks that it does. I probably could actually do that. I don't think there's really much that can go wrong that would require a jumper or what the thing is, oh my gosh, a breaker. I don't think that I'll need one ever. So, at least it's not like the CryoFlux with the DTC command, same name that a Linux tool uses. Oh, not, that's probably some time, right? That would make sense. So, okay, let's do GW seek -H, because this will tell us how to use it. So seek to the cylinder, arguments, cylinder to seek. Don't we need, oh, device tree compiler, yeah. Yes, using the CryoFlux on Raspberry was a pain with device tree compiler as by default. Oh, that is hilarious. Device name, drive. Yeah, I need to do drive. So let's do --drive 0. And then we will seek to 20. How about that? Track 0 not found. Okay, do we need to go to track 0 first? Boom. It's not working at all. device, does Linux bounce the USB ID around every time you plug unplug? COM port, I mean? Sometimes. It can happen sometimes. It already found GW info. It already knows where it is. So, I know it's already... I don't need to specify the ID. Why is it not interfacing with the drives, though? It's connected on the NOT twist. The interface stuff is all plugged in. Nothing weird going on. So it should be working. Why is it not? Drives have all their power. Pretty sure this worked with the CryoFlux. Seek drive 020. We have the adapter board jumper for IBM bus use. I don't think that'll make a difference. Drive A? Yeah, no difference. No change. ACM 0, I don't know what the acronym is. ACM 0, it's probably something to do with the microcontroller, because I've had different development boards that would show up as ACM 0 instead of TTY USB 0. So it's probably something to do like that. Drive A did not work. Wait, did Thinks Drive A worked? What? What? Why does that work? Drive 1. But that didn't work. Wait, 20. Oh my gosh. Wait, 2? Oh, that's infuriating. Okay, so it's 1 and 2, not 0 and 1. All right, sure, why not? Okay, so now we can do 77, and that should work. Excellent. And then it's already there. Yeah. Yeah. So, awesome. So let's do zeros. You guys want, let's do this view here. So I'm gonna send it back to 0. Boom. Then we'll send this one back to 0. Yep. Alrighty. Yeah, we could do that, Helen. All right, so that's all working. What do we got? So we want to read a disk. So we want to do read -H. So we have format options. I don't have a scroll wheel, so we're going to do Alt. Nope. Okay, we're going to BYOBU. GW read -H. Now I can do Alt page up. So we have to do device or drive again to 1 and 2. Disk format. Oh, that's weird. Okay, we're gonna do raw. So we're gonna do, I think this was 2 here, so we'll do that. All right. So we will do drive to raw and then a file. So is that just gonna read the whole thing? How do I, is there like a limit? How's this gonna work? So you just think about the chain of tech devices between the keyboard and the surface of the floppy disk. Dozens of processors. It is hilarious. Abstract communication model. Ah, okay. Interesting. So I don't see a sector count. Is it just gonna, how's it gonna stop? C equals 0. Oh, it's number of cylinders. Okay. Dash tracks, or T-spec. Where is tracks T-spec? Okay, C equals 0-76. Okay, awesome. Okay, so read device to, no, drive to dash raw dash tracks C equals 0-76. Boom. Error. Oh, file. Fair enough. Okay. You know what? mkdir. Actually, no. cd, tools, image. Okay, let's do mkdir test, cd test. Okay. Test. Boom. Okay. Unrecognized file suffix. Well, why do I have to provide it? It's raw. Is it HFE? Is that it? I think it's HFE. Or is it .raw? I think one is standard and one is cryoflux. I don't know which is which. Should I go look at this on their wiki? Maybe. Raw? Well, HFE is also a thing. I think raw is the cryoflux format, but you know what? Why not? It doesn't really matter. Bad cryoflux image pattern name. Yeah. So 00.0? Yeah. Sure. We be data-ing. Greaseweezle uses, I think, an ARM. It looked like it was just an ARM. Probably a STM or, oh, what was the other one? Atmega. Probably something like that. Blue pill based. I don't know what that is offhand. Oh, it's reading double-sided. I'll have to figure out how to do single-sided. STM32 ARM? Alright. Yeah, it's probably in the track spec how to do single-sided. I'll have to look at that again. H0? Alright. Thank you, J-Metal. Sounds like you got one of these. I will have an opinion on how well this works. Does it work with hard sector disks? I think so, but there's more to running it. So, oh, I guess I can be giving you guys this view because it's just imperceptibly moving along there. Boom. Okay. What I'm going to do here now is this CD projects. Cryoflux, which I should probably rename to Floppy. I need HX something or other, software, boom, LS, CD, Windows, wine, HX something or another, stopping, so what is this thing versus your cryoflux? Cody, they're kind of basically the same thing. This is just the open source version of it. So it does all the same stuff. The only real difference is that I don't think there's a GUI that will show the flux data as it comes in, which is, in the long run, I don't really care. But for video production purposes, that's kind of nice to have. But I think that's the only difference. Why did this not work? Is this actually the wrong thing here? Oh, yeah, because I want the HX floppy emulator. That's it. Boom. Okay. How do you get that bar on the bottom of the terminal? So I'm using a program called BYOBU. And I can type that in chat here. Yeah, Cody got it. And it's kind of like a version of Tmux. It allows you to do some other things. Like I can... if I click back to here, I can switch between two virtual terminals with F3 and F4, and if I really wanted to, I could split this one to have other ones. So I could do an LS in this directory there, and then Control D to close it. So yeah, it's just a wrapper for doing windowed terminal sessions with different buffers. really handy. BYOBU is kind of like a Ubuntu go-to option for that. So there's my super tiny HXC. Let's go to Home, Tools. Also, hello, Sprite Clad, since it's your first time chatting. Tools, image, test. And let's drop that in there. Make sure it did the floppy data reading. Track thingamajig. And 8-inch. Boom. Look at that. It's a floppy disk. Bingo. One thing we can do here, we can actually compare this to the other one, the other rip that we did. So what I can do is I can actually, you know what, let's not do it that way. Control D. I want to shift F2, and I'm just gonna run the exact same command, wine, hx, thingamajig, and then here, I'll go ahead and open the stuff from there. Oh, I moved them somewhere to here. Image from S100. This was Graph Talk. This is the copy. I want to see what these look like. Have you tried ZSH instead of Bash? Not really. I tried Zonch, and that was about it. I'm not a big fan of messing with the basic formula. So, all right. So on the left is the CryoFlux read of the disk, and then on the right will be the Greaseweezle read in a moment here. Once it figures out what it's doing. There we are. They look fairly identical to me, although, actually here, the way the Greaseweezle tracks are formatted is a little bit more like what I would expect. They go further towards the center. Is that because, oh, it must be because it's double-sided? It's the same number of tracks. So especially if we look, it's gonna be really hard to zoom this in. I will try here. If you look here at the red dots, you can see the clusters are the same between them. It's just stretched out. So what happened is the track per inch is being reported more accurately, I feel, with the Greaseweezle. I don't know why. Maybe it's something to do with the number of sides. If I do the Greaseweezle as single-sided, it might show up weirdly as well. I don't know. Yeah. Huh. Thanks for BYOB. You mentioned I learned a thing today. I wonder if it runs in native CLI frame buffer. It should, yeah. So, use KMag. Is KMag a Flex viewer? Because with the name Mag, I could see it being. I don't know. But yeah, I really like how that turned out. I don't know. Oh, you know what? It's possible I did it the wrong one. 8-inch 48 TPI. Okay, let me make sure I have it right over here. Track view, 8-inch 48 TPI. Okay, now they're the same. I don't know what I did before, but there we go. Now it's the same format. That looks like the dummy disc view rather than the 8-inch view. Yeah, it might have been it. Now I think I got it. The UI is really hard to read because it's all so small. There we go. Those look completely the same to me. Yeah. I like that. That's nice. Okay. So that's cool. Confirmed good read. Verified with known-ish functioning hardware. That's awesome. Now there's, I bet, enhance, I wish. It's just really hard to do. If I had some way, you know what? Actually, hold on here. Is there some kind of accessibility zoom feature? Zoom. Screen magnifier. Magnify. Let's try this. Oh, KMag and KDE is that. Oh, well, that's probably what I'm about to install here. Install. You can't see anything other than the number of characters, which, meh. So you get the other two drives working, archive twice as fast? I could. That's not really the limit. So, all right, here we are. Boom. Does this follow the mouse cursor? How does this work? Oh, that's a thing. All right. Okay, so here you can see some error dots. And then if I move it over here, so they're slightly less rotationally aligned on the Greaseweezle, but just barely. Off by 1 pixel. It's not KMag. I don't know. I'm just going to use this for now. So, all right. So I noticed down here there are some falling edge red areas. Convert both to an IMD file. I can't. I mean, do checksum. I guarantee it'll be different. I 100% guarantee it'll be different. We can try it, but I guarantee it's going to be different. Close. Close. This one is the test one. So we're going to do IMG. Why is it in there? Probably because, yeah. Oh my gosh, the file structure places. Yeah, let's see. Greaseweezle, boom. And export this. Cryo. Okay, let's see. So, home. See, Cryo is 3.1 megabytes and the Greaseweezle is only, oh wait, hold on, I didn't export as an IMG, that's my fault. Hold on, export. IMG, nope. IMG. Cryo. There we go, okay, they're both roughly the same size. So here's Greaseweezle, properties, checksum, calculate. Okay, ends in 8AB, Greaseweezle, or Cryoflux, checksum, MD5. Holy moly, they are the same. Whoa. Where did it go? Why did it close? Let me do this. More actions, keep above others. Look at that. Okay, so here is the Greaseweezle 84AB Cryoflux 84AB. Same data equals checksum. Same checksum, yeah. That is a desired result. I didn't expect that at all. I really thought they were going to be different. That makes me really happy that they can get the same read. That also makes me happy that all my monkeying around with this hasn't ruined that disk. Because I wasn't sure there. Same floppy should be same data. Yeah, just I was not expecting it to actually work out that way. That's phenomenal for multiple reasons. You know what also would be a good test? Let's read it in the other drive. Uh-oh, it's not ejecting. Does it have to be at home to eject? GW seek -- drive to 0. Ruh-roh. I would like the disc back, please. So, what's happened? There we go. Fun. That's the one that's always worked on. All right. Let's try and read it on that one now, though. Actually, I need to close and reopen that. Okay, do it a little more slowly so I can better center the disk. Much better. Okay. IMG's file system data, so you lose raw timings. Yes. So go back to... Actually, no, we want to be here. We're going to do this test -2. B. Actually, do test B. There. Let's do, whoops, that way. Drive 1. There it goes. Confirm both drives working again. That's nice. You missed what format? I converted it to IMG. I probably need to convert it to IMD. Have you tried Meta Plus 0? I don't know what that is. What did I just drop? Hopefully nothing important. I see a pen down there that I don't think was down there before. Maybe it's that. Finally out of the zoom zone. What? Zoom zone? Oh, you disabled desktop effects. Okay. Let's see. It was advice for getting out of KDE's desktop zoom shortcut. Oh, okay. IMD is best format for sector imaging these old CPM disks. Yeah, that's my suspicion. Really? Meta Plus 0. Oh, sweet. That is. That's excellent. Okay. Perfect. Okay. Keep that in mind. Why equals, though? Oh, whoa. I like that, too. Woo! Now what, though? How do I... Oh. Okay, this is better. I like it way more than the other magnifier. Yeah, that's the way to go. Okay. It read. See, which one of these? That one. Okay. So, I need to go to this. I'm going to close that one. We're going to keep the CryoFlux image open. Go to... let's just do it this way. Home. Tools. Image. Test. Then we got test B. Boom. Track analyzer, first off. Fun stuff. Yay. All right. And we can even... Whoa! Look at some sectors. Look at the data. There be data there. Ooh, that's cool. That spot's a little gross. I mean, but, you know... Oh, the line's looking much smoother on that one, so that's cool to see. This is awesome. Okay, I really like having this. Ooh, that's interesting. So I wonder if that's a spot where it was at the window for a while. So maybe same there. So maybe the disc, this was where the opening was and it got like dirt and stuff in there. Several positions where that may have happened. Interesting. It's in the four corners. I wonder if those could have been the edges where it was and it got crinkled. I don't know. That's strange, but cool to see. Zoom out here. Oh, I like that feature so much. That is awesome for streaming. Honestly, I kind of want it. Like, look, there's the software. You've never been able to see that before. Export. And now we can go to IMG file. Boom. And we're going to do Greaseweezle. Nope. Grease. Nope. Control A. Doesn't work in this program, it seems. Okay. Greaseweezle -B. Enter. It's exported. Zoom out. Home. Oh, wait, no. Let's go back. Home. Greaseweezle B. What's clicking over here? I don't know, but ejecting the disk fixed it. Okay, Greaseweezle B. Properties. Checksums. Calculate. Perfect. Oh, this is excellent. There we go. 2 identical checksums. Again, different drives. Booyah! That's awesome. I couldn't be happier with that. That is a really satisfying test there. And software. I'm having fun with that. That's nice too. Yeah, so now I know I can comfortably use either one of these. Wow. Cool. So Greaseweezle verified. I like the data format, how you read and write or access a Greaseweezle as well. So that's kind of nice. Do copy that floppy. So I'm not gonna be writing any. So we have 3 images. Is that enough for archiving? Yeah. That's 3 locations, right? Redundancy. Oh man. So we've copied it to the hard drive, Tiki Motel, but I'm not gonna be writing them back to any physical disks for a while. So yeah, that's excellent. Let's go ahead and you know what we could do? Let's try for giggles to read one of the disks that did not work. So here's quick code 2.1. Let's see what we can do with that. Oh, that sounds terrible. Let's lower that a little more gently. It's not tremendous, but we'll go with it. See, Chipmunk UK1, hello, since it's your first time chatting. Try one of the discs that would not work. Yes, I'm doing that right now. Okay, so go in here, just rename it bad, see what it does. I don't like this at all. It's stopping the disk. It keeps like clamping down on it. I think this disk is gross and that it's dirtying my head. Because why is the disk stopping? No, we're abort. Bad things are going down. That should not happen. Yeah, no. Poor floppy drive. I'm glad I had it open to see that. Ugh. I don't see anything catastrophic on that side. looks okay. I don't know. That's, ugh. Yeah, it looks all right. I don't know what the deal is. Yeah, quick use flux capacitor, go back in time. Yeah, what can we see if you shine a light through the disc? I can try that here. That is a tremendously opaque disc. Flashlight, disc. Like, whoa. It is right behind it. You cannot see that. Good disc. Very bright. Is that a moldy floppy? Is that what's going on here? What does HXC make of the raw files we have now? Will it load like 5 files? It complains a lot about stuff like that. Yeah, I don't think it even tried. It is kind of too dry in Arizona to get mold. I really don't see it a lot. There is some, but not much. Yeah, it seems like it started loading and then it just gave up. Yeah, 0 of 77. It's, yeah. That is weird. I don't think it was, like, clamping down every track before, either. I'm not sure if it's actually going to even load it here. I don't know if it knows what it's trying to do. So I gotta say, I absolutely love the face cam setup here. Facial recognition at its absolute best. Yeah, it's a really handy way of doing this. That was one of my better ideas that I had to get that implemented. I mean, it's not like I wrote the software's by someone else, but it's really handy, and I feel like this is a good application for it. Yeah, I think I can give up on this trying to read this. So, there were so many flex changes it recorded. Maybe it tried to do something with that. I don't know. Is that what you think it's doing? If you can tweak the face cam script to stay on its last position when it can't find your face. Yeah, so I've talked about this before. The way that it works is it is emulating a PTZ controller camera. And that's a camera that has motors that rotate around. So when you have a camera or the motor system, it can only tell the camera like rotate left slightly. And then it would tell it rotate until your face is in the center. So what happens is when your face is gone, it tells it, oh, rotate to face, but then it never finds face. So it ends up drifting off to the side. Because this exact same software can be used with a physical, literal camera moving piece of hardware that could track a face without panning the digital image. So that's why it does it that way. It's very weird that that's how it emulates it, but it allows them to have one code base for both physical movement and software movement. So, yeah. That behavior should still be a toggle. Well, it's because it loses track of the face and it's just at the last position. What it should do, well, it does actually have this. It just is really terrible. It should have a timeout where if it doesn't find a face for a certain amount of time, it just zooms out. And it will do that. It just takes way longer than you would think it should. It's a confidence-based system, and the confidence values, even the minimum confidence, is way too high, in my opinion. So it's still trying to load it there, I guess. Maybe. Just like humans. Since progress bar keeps moving, I'm just inclined to let it finish and see what happens. Man, now that I can crop the video on the fly here, having the 4K monitor is actually kind of nice, because I can, like, everything looks really good. That text in the background in the terminal is super legible. So that's kind of funny having that. That looks slower than a floppy drive. Yeah, there's something not right going on here. It's not happy. I bet it's not going to be able to display it. So now I'm having fun with the K1 magnifier too. It's nice. I like it. See, I was suggesting the native Linux HXC tools, but this looks better. I would still be interested in that. Where are they? I'll have to look into that. I don't know if it has the flux radial disk physical literal view, whatever thing you want to call this stuff. Because that's the only reason I use the HXC. Well, that and the conversion, but yeah. I would want to have that. I think there's a dedicated Apple II disk visualizer. I don't know if that's something that also works with other stuff. I don't know. Wow, this is so slow. Oh my god. It's only reading track 0 right now. I just noticed. There's no way this is going to finish. Okay, we're aborting. There is a 0 chance it's actually going to finish. Okay. We can close this because it hasn't actually cleared that out. HXC is just Java. It is an actual exe file. But do you think that there is a Java version of it? Because that would be nice. CryoFlux is a jar. It being Java could explain why its UI toolkit doesn't scale. But, yeah. It's the same version. I've just found out that it can be compiled on Linux. Really? Emulator software. Well then, I will have to look into that, because that would be super nice to have a native version that would scale the UI correctly. Oh, that progress bar is for the whole disk? Well, did it just finish? It did finish. Oh, look at that. Whoa. It says no thank you. Wow. Look, there's a little bit of data right there. You can almost see data on the outside there. Okay, so that's a no. Wow. That's weird. I don't know, that could be an interesting case study for me to try and clean a disk to see how that works out. I'm not particularly inclined to try it at the moment because I don't really have any ways of doing that. But that could be interesting. So, yeah. Let's see, what do we do from here? Whoa, 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 whoa. Why is that not spinning? The floppy drive fan is no longer spinning. Why? Why is it jammed? What is going on there? Oh, it is. That motor is so mad. Somehow that got pushed out and it apparently can just jam up against that. Okay, that's cool. Oh, it's so hot now. Well, I'm glad I caught that. There we go. I'm gonna let it run just so it can cool its own transformer there. Man said my work here is done. Yeah. When you had it upside down, yeah, probably bumped it. Yeah. Yeah, but it moved out on the motor shaft and was colliding with the rear finger guard, because that's where all the safety is. It's in the rear. Inside, they assume that if you go in here, you know what you're doing. Which apparently I did not, because that was bad. Change it with a Noxwood DC fan? Yeah, that would not be a bad idea. Although I mean, it's horrifying, but it's also cool how finger choppery it is, and vintage. So I kind of don't want to modify it. But on the other hand, it's terrifying and probably awful and really inefficient. So I probably just should. You can get 24-volt Noxwood fans, I think. Pretty sure you can for industrial uses. Which, you mean, this is a hair away from industrial use, so. I'm really happy with this floppy drive, how it's turned out. I feel like it's just doing really well now. I was so bummed yesterday when it stopped working right. Man, I wish I knew what happened, but at least we have a solution that still works. So it has plastic blades. It's not metal. It's not that scary, and they're not like sharpened. But yeah, it's this is in much better shape than it was yesterday. Both Paps have really good industrial fans. You know, you say that, I'm not sure, Farer. Every Pabst fan I've encountered, I've had to replace. All of them. I thought I had one over here as an example, but apparently I do not. Oh, I haven't put the fan in the other HP power supply. I should do that. But yeah, it's no Pabst for me. The bearings are always going bad. You can't beat their metal shrouds though. Those are phenomenal. See, you threw a Phoenix down on it, and it actually worked. And no one has a complete idea why. I'm not sure. I don't get the Phoenix down reference, but yeah, it's working now for sure. Oddly, why can't I control the secondary camera? Oh, I know, because that's active. And now, ooh, I don't have a key. I forgot to put a key on there for that. Okay. I'm going to do that right now while I'm thinking about it, because I will forget. Lock. No, it's there. What gives? Yeah, weird. All right. Oh, okay, the button wasn't working. So I have the ability to cycle through all the cameras here, and I had a setting that I did where I can force it to always be that, and I kind of had to do that for the split camera view, because you might have it be where it's something else, and then there wouldn't be this camera. So I had to adjust that. But yeah, that was not set up the correct way. There we go. Let's see. Oh, Final Fantasy. Yeah, I've never played Final Fantasy, so I wouldn't know that. Oh, man. All right. I think it's time to wrap this up here. We need to... I need to come up with a good workstation workflow area for actually doing scanning and stuff that I can leave this set up and not need to like bring all this, drop it on the table and have it take up space, because I want to be able to have this set up somewhere where I can just go sit down and actually do some archiving rather than have to make it like a whole event. Reduce the effort to get into it. That'll make it more likely to happen. So I kind of want to figure out if I have somewhere I can set this up for that here. I'm not sure. It's gonna be a little hard, but I'll figure it out. So yeah, that plus scanner under the desk, that'll eliminate some of the fun for the video, but maybe it could go under there. I also don't know how much weight I want to put on these. The wheels on these workbenches are really not awesome, so I wasn't able to mount them quite as well as I wanted. The fan stopped because I turned it off. That's what happened. So it's good. It's fine. So yeah, I'm going to try and figure out somewhere for these things, the scanner and this. But yeah, I think that's it. Yeah. Since I got lost in the fan scare, I got some compilation hits for from so Arch Linux has it. I've had mixed success with their stuff for their package builds. Like they have one for DaVinci Resolve. It does not do, and it's not helpful. But I'll try and remember that and take a look at that. Let's see. No fire, please, thank you. Yeah. Are Data General 8-inch drives similar? No, they're completely different. Entirely. That's one of the things. I can actually come back over here. I can grab a Data General disk. So this is actually one of the benefits where the Greaseweezle might come into play here. We're gonna have to experiment with the Greaseweezle one day, because we need to do that. But this is a Data General disk. You'll notice there are two holes right there. This is a hard sectored disk, so there are more index holes. There's one index hole for every single sector, and then this is actually where sector 0 is. So this is weird, and I tried to rip this with the CryoFlux, but I couldn't get it to work. I need to do more research. I think it can, from what I've been told, but this is a more complicated thing to try and read. But the drives work fundamentally differently because of that. So the hard sector Data General drives are a completely different thing. They have their own control board that is tied to the drive logic. Like, we had to work on the PCBs that control the drive interface, the ones that are down here. On the Data General, essentially, the interface board like this is integrated into the drive logic boards. So it's all one, kind of like how the Apple II is. So it's not as easy to work on those drives, which is why these are awesome that I got with the S100 stuff, because these are going to allow me to read those disks actually, hopefully with the index stuff figured out. So yeah, that's what I'm hoping for. But yeah, let's see. There's also a flat pack. Maybe that could probably just work out of the box. So good stream, longer stream tomorrow. No, this is about the limit for how long I want to stream. Any more than 4 hours becomes very tiring. But let's see. And also no stream tomorrow. And I did fix the Saturday schedule, so that's back on the website. So yeah. Oh, hard sector, that's exotic. Yeah, it's a bit. It's not common. See, H89 is hard sectored. Oh, that sucks. I didn't know that. That's really annoying, because that's such a pretty and kind of iconic computer. That's too bad it's weird like that. Now, if you have nothing against flat packs, well, I will definitely have to look into that. See, if these drives have fast index circuit, yeah, that is a thing too. That might be a problem. Well, again, the Greaseweezle software, let me bring that up actually. GW read H. Okay. Laptop capture. Let's look at that, because I'm pretty sure this has the fake index, so fake pulses at speed. So I'm hoping what that means is that it can ignore the drive index sensor at all and then just read it. I'm not sure how you like rotate the data correctly then, but I'm hoping that that makes it work with like any index layout, but I don't know. I gotta research. That's one of those things that it could be what I'm hoping for, but it might not be as well. So I gotta figure that out. There. So yeah. Let's see. What's the difference between the CryoFlux and the Greaseweezle? The Greaseweezle is open source. You can go to the GitHub repository, download the PCB design files, the software that I'm using there to interface with it, and you can modify it and do whatever you want. The CryoFlux is not open source. As far as I'm aware, it sounds like Hellencroft might have actually found design files for it, so maybe it sort of is. I don't know. It's a lot more expensive as well, and when you buy it, you actually have to agree to which version you're getting. There is a standard one that's meant for enthusiasts, and then there is a professional version if you're going to use it professionally, whatever that means. I honestly wouldn't be surprised if they consider what I'm doing here to be professional, because I make money off of ads and support from you guys while I'm using it for stuff like this. So I find it legally complicated with the CryoFlux, so kind of like the idea of the Greaseweezle, that it's just, oh, it's free, go get one, it's cheap too-ish. You know, I paid $50 for the Greaseweezle. This one, I got this for pennies basically, because it was in a big lot of computer stuff, but normally it's like $150, so really expensive. Open the CryoFlux folder. Are the source files just in there? Do I already have them on my computer? That'd be kind of hilarious. Let me see. Home. Project. It's a bunch of files I put together, so it's not necessarily going to have it. CryoFlux. CryoFlux Linux. Schematics. Well then, okay. They are in fact in there. It looks schematics. Okay, so it's semi... Well, there's a license in there, isn't there? Let's go look at it. License. Anytime you come up with your own license, it's not really open source. So it's sort of semi-open source, because it's Software Preservation Society license agreement. So I don't know what it is. They got a lot of words they want to tell you about what they think about this product. So if you really want to know, you can go read that. But I consider it semi-open source then. Maybe look, but don't touch. Like the SimH license drama. Yeah, that one's fun. So I don't know. I don't know what it is. DTC. Yeah, you probably can get the DTC software then. That's even less special than like the firmware and stuff on this. Oh, that schematic doesn't necessarily include firmware, so there's that. I don't know how that works. So I was thinking about getting a CryoFlux, but the Greaseweezle is cheaper and has the same functionality. I'm gonna get one of those instead. That's what I would push for. Yeah, I'm probably gonna do a video reviewing the Greaseweezle. I think I want to get a little more familiar with it. I'm thinking about doing a shootout between the two. It's a little difficult to make a video about that because it just works. I mean, it does exactly what you want. So it's schematics README is smaller. Let's see. Oh, that also doesn't have line breaks. So I don't know. I'll try and look into making a review video. So yeah. Hardware design itself is free to explore and experiment with, notwithstanding. I love how that's one word. I love it when words get concatenated like that. At least needs to be one word, just as an example. There is no instance where you would ever need at and least to be separate, and it doesn't flow together like normal language. Anyway, notwithstanding of the terms of the license, you are allowed to change, modify, improve hardware designs provided as long as you make your changes public and freely available as well. The design may not be exploited commercially. PCBs or assembled units sold where money is changing hands. See, so that is slightly less open source. You can't charge money for assembled units, so that's basically non-compete. It's open source with a non-compete. Wow, okay. And if they have CryoFlux in their silk screen, you're not allowed to use that. And it actually, CryoFlux is in the copper layer here. So if they provided Gerbers, you couldn't actually use this, make those Gerbers because it says CryoFlux on it. Semi-open source. That's what I'm going with. Semi-open source. I appreciate their effort. I mean, it works. It does what it says on the box. You know, I have no problems with it as a product. The only thing is that it's expensive. They have weird licensing restrictions for something that is honestly one of those things where you just want as many people using it as possible at this point. So yeah, it's just, I don't know. Hello, Linux man. So yeah, I don't know. I'm gonna recommend Greaseweezle. That's about it. Check out the GUIs and stuff, but there's a reason CryoFlux has some drama attached to it. I'm so tired of software and hardware drama. So tired of it. That's where just giving stuff away for free makes everything easier. So yeah, all right. I think we should wrap this up because we hit our objectives today. We got the Greaseweezle working. And how'd the stream go today? I'm kind of going to get a wrap up here. It went well. We got the drives fully functional after yesterday's stream, which is a big relief because I was really concerned about that. I did not know how the drive failed. I guess I still don't. We changed something outside of this and it made it work, which is frustrating, but can't always know all the answers. I feel confident. Well, that's okay. These maybe are not working as well as I thought. Like this one will not eject. So I might need to take the faceplates off and stretch the springs, like I was saying. But I know better how the mechanism works, so at least I know I can repair it if I need to. So if I like rotate it down, maybe up. Yeah, I don't know, but I do feel a lot better about the drives and understanding how they work. So at least there's that. Fixing that probably won't be too difficult if it is an issue. Yeah, I can't hear you all over the nope in the room. Yeah, just use what has the best workflow. I agree. That'll be what I will use. I'm gonna figure out what makes the most sense, and I may actually end up using the CryoFlux more in videos because it's more visual. I don't know. I really like the CryoFlux software as far as streaming and recording what stuff looks like. So there's that. So yeah, I don't know which one I will go with. And I might even end up building one of them into an enclosure with the floppy drives, and then I would just use that one. So I really don't know. So you can take the front off. Yeah, I can't. Okay. One of them just released on its own. I can take the front off while it's in the case for sure. Yeah. So that will be even easier to work on. So yeah, it'll be interesting. I'll think about doing a video shootout between them. I should probably look into more about the legaliness of the CryoFlux. I think that'll be the complicated sticking point. So yeah. But all right. Yeah, I'm happy with how the stream went. Got everything working. Ignore the latches. And I definitely feel like I can start using this again for disk imaging. And I'm a lot happier with how it worked. Although I didn't get those cleaning discs ordered. I will have to do that today so that I know I can clean stuff when I have the ooky, gross drive or discs like this one that'll stick. That was really weird. I've never seen that before. So yeah. Yeah, went well. I'm happy. Hope you guys enjoyed this stream. I think I know what the next one's going to be. I kind of want to take a break from the S100 stuff and just play around with something weird. And I picked up a typewriter that there's almost no chance I'm going to get working, but I kind of want to just open it up and poke around because it has two 5¼ inch floppy drives in it. Typewriter. Yeah, should be interesting. So that'll be Wednesday, I believe. So tune in for that. But for now, that's it. Let's go ahead and run the outro here. Boom. Oh, I forgot the printer. All right. Thank you guys for being here. This was a lot of fun. As usual, you guys were a lot of help in getting this stuff working. I really appreciate it. I'm just thanks for being here. Hope you guys enjoyed this one. If you're watching this video on YouTube and enjoyed it, you might want to subscribe to the channel. If you're here on Twitch right now, you can follow to get notified when I go live again. If you want to support the channel, you can buy a shirt like this one or find me on Patreon. But that is it for the moment, and I will see you next time.